Let's see the next problem of asymptotic notation. Right? See, next problem. Read this one. Find true statements. Find true statements from the following. Right? This is the one more problem. Right? Let's see. Like how you solved the previous problem, similar way. If anything new, please learn. If normal, it's okay. Right? Mostly I am thinking that you can easily give answer. One or two options may trouble you. Right? I will explain. Right? Let's start this. So, which statements are true we have to identify. Can you help me? What about option A? 1 by n is theta of 1. Is it right or wrong? So, before going to the option A, let's see the option B. 1000 is theta of 1. Is it true or false? 1000 is theta of 1. Right. Let's see the option B. Option B is right or wrong? Afterwards, after B, I will go to the A. Right. Let's see the option B. 1000 is theta of 1. Is it right or wrong? Of course, because left hand side is constant. Right? Left hand side is constant, right hand side also constant. Some people are asking me, right? Some people are asking me, left 1000 there, right 1 there. How can you say both are equal? How can you say that? Right? There is a C may be 1000. Then I think both will be equal. So I think everyone, theta means not equal. Theta means big O also, omega also. You know this very well. So theta means asymptotically equal, not mathematically equal. That's fine. What about option B? Let me see this one. Option B like this one. 1000 less than or equal to some C into 1. C may be 1000 or 1001. So that right will be greater or equal. That's okay. Can you say C value 1000 or more than 1000? Then big O possible. C value 1, then omega possible. So theta possible. I think now people got to know. Now people got to know. Can you help me now? Every constant in the first, right, this one. In the first lecture or second lecture itself, I written one line. What is that one? Every constant can be written as big O of 1. This is the reason. Every constant, right? I have 10, right? Instead of saying 10, say the big O of 1 or omega of 1. That means theta of 1. Starting itself, I want to say theta of 1. You may be confused. That is the reason I didn't say. Right? Now onwards, you are fine now. Every constant can be written as theta of 1, which is nothing but big O of 1, omega of 1. So, option B is a true statement. See, big O possible because of this. See the omega also if you want. Greater than or equal to some C into 1. C value 1. Omega also possible. Then theta possible. Option B, everyone know that. That is the true statement. Let's see the option A. Right? Let's see the option A. See the option A now. Now, can you help me now? Option A, if you observe, what is the left side? 1 by n. Left side is 1 by n. Right side is 1. These two are equal, right? I think everyone knows this one. What about option A? These two never be equal. What is the reason? It is the 1 by n. It is the 1 by n. 1 by n, if you multiply by n, then only 1 will come. 1 by n, if you multiply by n, then only 1 will come. What is the meaning? I think 1 is going to be n times bigger than 1 by n. Can you help in 1 by n and 1? Who is bigger? 1 is bigger. 1 by n and 1, right? 1 is bigger. Can you help in option A? Option A, big O possible. Let me check. 1 by n is less than or equal to some C into 1, right? C value 1 or more than 1, 2 also okay, right? If you want, you can check, right? Big O possible. So, n increases, value will decrease, right? I think everyone, left value cannot go more than 1. Right will be already 1 or more than 1. Is n increases, right? Value will decrease here. But it is, right? It is depending upon C value here. C value, if I take 2, always bigger. If I take C value 1, first time both are equal, afterwards left will be smaller. So, what is the meaning of big O? Right will be greater or equal? Equal also okay. Right? Sometimes may be equal, but most of the time right will be greater. Everyone know option A, big O possible. See the big option A, omega. Theta means what? Omega also 1 by n greater than or equal to some C into 1. Can you help me now? What C value I should take so that left will be bigger or equal? What C I should take so that left will be bigger or equal? What is the answer? N. N or what? Right? I think 1 by n. 1 by n. Right? C value 1 by n. C value, if I take 1 by n is greater than or equal to 1 by n. Then only 1 by n is a function. 1 by n is a function. So, you cannot take. So, everyone knows this one. Option A, big O possible. Omega fail. So, theta fail. theta fail. Please be careful. And one more thing, where is the chance of theta, right? 1 by n is left side, right side is 1. What is the meaning? This 1 is n times bigger. This 1 is n times bigger means what? If you divide by n, then only both are equal. If you want to say this side also, it's okay. 1 by n, if you multiply by n, so you are multiplying means what? E is smaller n time. What is the meaning of E is bigger? Divide by n, then only both are equal. So comparing left one and right one, right? Left one is going to be n times smaller comparing with the right one. Then where is the chance of both equal? So big O possible, omega possible, theta no chance. But one thing is true, big O possible means less than or equal to, omega not possible means theta not there. Theta not there means equal not there. It is actually small o. He is saying theta, that is the reason fail. If it is a big O pass, everyone knows small O pass means big O also pass. Small O actually it is a small O. Small O pass means big O also pass. But omega not there, so theta not there. So actual answer is going to be, right, for the option A, big O possible, small o possible. But anyhow, he is asking theta, that is the reason fail. Option A fail, option B pass. Right? Let's go to the option D. Let's go to the option D. Afterwards, I will go to the option C. Let's go to the option D now. Right? Option D, if you observe, see this one. In the power log is there or not? In the option D, if you observe, in the power log is there. There is a one formula. In the power, if at all in the power log is there is a one formula. Let me see this one. What is that formula? Please listen. A power log n base b is equal to, there is a one formula in the logarithmic. See this formula, remember this one. You know many logarithmic formulas, right? I am saying one more new formula, or if you know already, it's okay. A power log n base b is equal to n power log a base b. Please be careful. In the power log is there, you can utilize it. In the power, if at all log is there, you can use this formula, right? Some people are asking, sir, how to use? Let me check here. In the power log is there, you can use this formula. So what is the answer? N will come down, 64 will go up. N power, right? Log 64 base 4 into, what about the here also in the power log is there? N power log 32 base 2, right? This will go to 64 can be written as N power. What is the answer? Log 4 cube base 4. Next one, n power log 2 power 5 base 2. It will goes to, what is the answer? N cube. It will goes to n power 5. Both combinedly n power 8. So from the left side, what is the answer? N power 8 came. From the left side n power 8 came. Right side is theta of n power 10. Can you help me now? Left n power 8, right is n power 10. Big O possible. Small o also possible. Where is the chance of omega? Where is the chance of theta? What is the answer? Option D fail. Can you say, if at all big O pass, if it is a small o also pass, omega no chance, theta no chance. The purpose of the fourth option I given is to say this formula. Some students are asking, sir, when can I use this formula? What is the answer? In the power log is there, you can apply this formula. Right? Please be careful. In the power log is there, you can apply this formula. You remember it. See, some students are asking me, sir, I know formula, how I know what place I have to use? That is the meaning of learning. Right? You know this formula, right? At which place you have to apply, right? When you practice more problem, you will get. Through experience, I got to know that in the power log is there, right? That time you remember this. Mostly it will be helpful. So, fourth option is fail. Fourth option, big O pass, omega pass. Actually, sorry. Fourth option, big O pass, small o also pass, omega fail. Right? Actually, fourth option is small o. Small o pass means big O also pass. Right? But omega no chance, that is in theta no chance. So I think every option you are okay. Let's see the option C. Let's see the option C. Careful, option C. Option C, read it. N plus a whole power b is equal to theta of n power b, where a and b are constants. N plus a whole power b is equal to theta of n power b, where a and b are constants. Right? So that is the given statement. Before going to give answer for this, right? Before going to give answer for this one, let me write the few statements. Let me write. Mostly you know whatever I am going to explain. If anything new, please learn it. See this one, you know very well. See this one. N plus 7 whole square. See this one. It is a constant, it is also constant. N plus 7 whole square. Can you say n plus 7 whole square? What is the formula? A square means n square, 7 square plus 2 into n into 7. n square plus 7 square plus 2 into n into 7, right? These are the terms, right? And one more thing I want to ask you, if it is the whole square, right, 3 terms will be there. Please be careful. If it is the whole power 3, 4 terms will be there. 2 means 3 terms, right? 4 means 5 terms, 3 means 4 terms. You just remember this one. And one more, n is there, n plus 1 terms will be there. And one more thing I want to ask you, n plus 7 whole square, 3 terms are there, it's okay. Can you say among all these terms, who is the bigger? Everyone know. N and 7, who is bigger? N. If n bigger, right, n square definitely bigger. Right, 7 square is smaller. Combination of n and 7, it in the middle. Right, so everyone know this one, n square is bigger among all. Now can you help now? Whole square, how many terms came? 3 terms came. Can you help now? Among all these three terms, which one is bigger? N square bigger. If n square bigger, see this one, if n square bigger, this is the less than n square. This is also less than n square. N square bigger, it's okay. It is the less than n square, it is also less than n square. This can be written as, this can be written as, see this one, it is only bigger. Next one, it is the smaller, it is the middle. Among all these 3, it is the bigger one, n square. This can be written as like this one. See this one. This can be written as less than or equal to 3 into n square. Because I took little bit bigger. Even though here is 7 square there, I took n square. Even though here 2 into n into 7 there, I took n square. Totally 3 n square came. Because of little bit extra, I am taken less than or equal to. If I don't take more, if I don't take less, so equal. Because of I am taking little bit extra, it became, right, less than or equal to 3n square. This can be written as less than or equal to some c into n square. This is nothing but big O of n square. This is nothing but big O of n square. Right, I think let's see this one. See this one, n plus 7 whole square, actual meaning is this. I took the, right, I took everywhere bigger, so 3n square. Because of I took little bit bigger upper bound, right, less than or equal to 3 into n square means c into n square, right, 3 is a constant, so big O of n square. I'm thinking that you are almost comfortable, right? Let's see one more case also. Let's see this case also, you may get more clarity. See this, n plus 7 whole cube, see this also, n plus 7 whole cubes. Can you say what is the formula? A plus b whole cube, a cube, b cube. Next one, 3n square b, 3n square 7. Next one, 3n, 3a b square, 7 square, like that. How many terms are there? 4 terms, right? So whole cube 4 terms are there, it's okay. Among all the 4 terms, who is the bigger one? N cube. It is smaller than n cube. It is also smaller than n cube. It is also smaller than n cube. Among all, bigger one is n cube only. Even though they are small, I am taking n cube only. Means less than or equal to 4 into n cube. So I think 4 is a constant. This can be written c into n cube, right? Which is nothing but what is the answer? Which is nothing but big O of n cube. Big O of n cube. Now I think it is the correct time to ask you, please help me now. N plus 7 whole power, n plus 7 whole cube is, right, big O of n cube. Is it right or wrong? Yes, right? Can you say which C value big O possible? C value 4, right? I think totally 4 terms are there, I written 4. Because of more I am taken big O, right? The actual thing is this. See this one, n plus 7 whole cube means the actual meaning is this. Very big sentence is there. The actual meaning is this one, right? But I took the larger one, n cube, so 4 times. Because of bigger I am taken everywhere. So it is upper bound, big O possible. For C value 4, big O. Can you help me now? For which C value omega? What is the answer? If I take C value 1, n cube, what is the meaning? If I take only this term, then it is smaller. If I take all, then equal. If I take everywhere bigger, then big O. If I take only first one, omega, can you help me now? For which C value big O? For which C value big O? 4. Can you say for which C value omega? Let me write this one. N plus 7 whole cube, right? Greater than or equal to some C into n cube. C value 1. If I take all, then equal. If I take everywhere bigger, 4 n cube, then big O. If I take only first one, omega. Right, this is going to be omega of n cube. So big O possible, omega possible. Can you say this one? N plus 7 whole cube. For which C value big O? 4. For which C value omega? N cube. For which C value omega? 1. Big O omega possible, then theta. Can help you now? In this one. For which C value big O? 3. Can you say which C value omega? Let me write now. C value 1 you can take. If you take all equal, if you take everywhere bigger, then it is going to be, right, big O. Right, if I take only first one, omega, big O omega possible, then theta. Now come to your problem now. N plus a whole power b. Can you, how many terms will be there? B plus 1 terms will be there. Right? This can be written as, I am writing here. This can be written as less than or equal to b plus 1 into, right? What is the answer? N power b. B plus 1 into n power b. Right? N power b. This b plus 1 is a constant. This can be written as c into n power b, which will goes to theta of n power. Can you say which C value big O? B plus 1. Which C value omega? 1. Big O omega possible? Theta. So, I think for the option C, right? Option C, two things I explained to you. Option C. So, whole square also I explained, whole cube also I explained, right? For whole power b, same thing will happen. B plus 1 terms, n power b. B plus 1 is a constant, so C into n power b. Finally, theta of n power b, right? So, finally, for this problem, please let me know which options are true. For this problem, which options are true? Let me check this one. Option A failed, option B pass, option C pass, option D failed. So, finally, B and C pass, right? You know very well, from this year onwards, multiple select questions are there. Means more than one option may be right. So, for this problem, B and C right. Right? Please learn. If anything is new, please learn it. Right? I am thinking you are comfortable. Right? Let's go to the next problem. Right? See this problem also. See, I think three functions are given. They are asking, write in asymptotic ascending order. Asymptotic ascending order. Let me check here. It is the n factorial. It is the n minus 1 factorial. It is the n minus 1 factorial plus n. Now, let me ask you one small line now. This is a very simple problem, everyone know. It is the n minus 1 factorial, it is the n factorial. This can be written as n into, what is the answer? N minus 1 factorial. N into n minus 1 factorial, which is nothing but n factorial. This is only n minus 1 factorial. Right? This is going to be n minus 1 factorial plus n. Now, can you help me? Among all these people, who is bigger? He is n times bigger. Right? Next one is a n minus 1 factorial. It is also n minus 1 factorial plus n, that doesn't matter. These two are asymptotically equal, you know this. These two are asymptotically equal. Right? So, plus n you are doing, that is into n, it is n times bigger. This is the only plus n, this is the only plus n, so it is negligible. These two are asymptotically equal. Can you help me now? What is the relation between all these things? Which are smaller here? Which are smaller here? I think Fn, sorry, which are smaller? Gn and Hn, which are both are equal. Let me write now. Gn is equal to H of n. That is fine. Right? These two are less than F of n. They are asking write in asymptotic ascending order. Right? Gn, Hn both are equal, which are smaller also, less than Fn. If you want, you can write whatever order you like. Right? Hn and Gn, write any order because of it the ascending order. Right? First smaller should be there. These two are small, which are equal also. Write any order. So, what is the answer? This one may be the case. N minus 1 factorial. Next one. N minus 1 factorial plus n. Next, n factorial. This is the order. If you want, you can spare these two also because both are equal. You can write in any order. Right? This is a very small problem. Everyone know this. Right? If something new, please learn it. Otherwise, it's okay. Right? Now, let's go to the one more problem. Right, this may be I think a lengthy problem because see, almost like 9 functions are there. Right? This is also same thing like previous problem, but here 9 functions are there. Right? So, write following function in asymptotic ascending order. This problem, previous problem, same. Previously 3 functions are there. Now, here 9 functions are there. You should write in the ascending order. Smaller to bigger, you have to write. Right? Please read once and we will arrange one by one. Mostly you know all of them. Only for namesake I am giving because practice purpose I am giving. Read all the functions. Many things, most of the things, 90% you can give answer. 1 or 2 small mistakes are there, right? We will solve now. F1 of n, n power log n base 2. F2 of n, log n whole power log n. F3 of n, n factorial. F4 of n, log n, log of n factorial. F5 of n, log n whole factorial. F6 of n, root n. f7 of n log n factorial, f8 of n 2 power n, f9 of n n power root n. These are the 9 functions given, right? Asymptotic ascending order you have to write. Right, start one by one. At anywhere confusion is there, we will rectify. The purpose of giving this problem, please remember, the purpose of giving this problem, not to confuse you, not to confuse myself, not to confuse anyone, right? We will try our level best. We all combinedly try our level best. If anything new, we can learn it. I done many times this problem, mostly I will help you, right? Please start. I done many times, mostly you are okay. If anywhere if you trouble, right, I will help you. Okay, can you help me one small line now? Among all the people who is bigger? Among all the people who is bigger? Is there any n power n? No. N power root n? Yes. N power root n there. 2 power n also there. 2 power n also there. It is the root n, it's okay. Where is the n power root n? Where is the root n? Right? So this one afterwards we will see. This is the n factorial. N factorial is very close to n power n. But one thing, n power n is bigger, this is smaller, it's okay, right? Both are very close. N factorial, n power n, almost close, right? Now let's see this one. So if everyone, n factorial 2 power n, who is bigger? N factorial 2 power n, who is bigger? You know very well. N factorial is bigger. N factorial and n power root n, who is bigger? N factorial. What is the reason? N factorial, if you see, n into n minus 1 into n minus 2 into n times you are multiplying. In n factorial, n times you are multiplying, but here only root n times you are multiplying. That is n times. F3 function, if you see, n into n minus 1 into n minus 2 into little bit decreasing, it's okay, but here n times multiplied, but this is multiplied only root n times. This is multiplied only root n times, right? Please be careful. Right? Now, if anyone having small doubt also, let me check here. If anyone having small doubt also, see this one. This is n factorial, it's okay, right? Can you help now? This is n factorial, it's okay. That is n power root n. If you have small doubt also, this is n factorial, that is n power root n. If you have small doubt also, this is n factorial, it is very close to n power n. It is n root n, right? But this is, you also know, I also know, it is bigger. Root n is, right? N factorial is bigger. N factorial is bigger because it is n time, it is the root n time. Still if you have doubt, n factorial, n power root n, still if you have doubt, apply log. If you apply log, it is a log n factorial. It is going to be root n log n. Right? This will goes to everyone now. This one. This is equal to n log n. We done already some problems also. It is the n log n. It is the root n log n. Log n cancel. It is going to be n. It is going to be root n. This n can be written as root n into root n. Root n cancel. I think this is root n. So what I want to say is n factorial is bigger. I want to say that. Right? See this one. These two things. Right, everyone now, it is the root n times multiplied, it is the n times multiplied. Little bit decreasing, it's okay, n times multiplied, it is a bigger. Still if you have doubt, apply log both the side. Log n factorial, root n log n, right? So log n factorial is, you know very well, using Stirling approximation, it became n log n, right? It is the root n log n cancel, remaining is here n, it is the root n, so n bigger. Still if you have doubt, root n into root n is n, this is the root n cancel, left root n is left out, right is nothing. So n factorial is bigger, everyone now. Now let me give some numbers, Can you help me now? Among all the people, who is bigger? If any change is there, afterwards we will change it, right? Let me give numbers as of now, whatever we can, right? This is the number 1, I'm thinking. Any change is there, afterwards I will change, it is the number 1. Right? Next one, can you help me now? 2 power n, n power root n, who is bigger? 2 power n, n power root n, who is bigger? Right? I think this one. This is small number 2 multiplied n time, small number 2 multiplied n time, but big number n multiplied root n time. Who is bigger? Who is bigger? If you have small doubt, apply say. This is going to be n log 2 base 2. This is going to be root n log n. This is going to be root n log n. Right? If you go further, maybe we done already, right? If anyone is getting little bit benefit also, please take. Mostly many people know n root n log n. This can be written as, right? Root n into root n. This is a root n log n. Root n cancel. This is going to be root n, this is going to be log n, every one now root n bigger. Root n and log n, root n is bigger. So I think now 2 power n, this is the interesting thing about this is small number you are multiplying, here big number multiplying, but n times multiplied, here only root n times multiplied. Small, even though small one, you are multiplying huge number of time, n time. Even though it is bigger, you are doing less number of time. This is the life. So from this one, see, smaller one is multiplied many times. Bigger one multiplied is less time. Then finally, smaller one multiplying n times is dominating. From this, you have to learn one thing in your real life, right? That is, right? If you do every day, even though little bit also nice work, that is okay, right? Every day you do. Every day if you do little bit also nice work, right? Overall achievement if you see, great thing. Some people, what some people will do is, one day they will study 24 hours, right? Afterwards, next 1 month they don't study at all. There are some students, one day they will study 24 hours, day and night they will study. Afterwards, 1 month they don't study, 1 week they don't study, then you don't get the nice rank. If you want to get the nice rank, what is the answer? Every day, you should have consistency, right? Do more days, right? Every day, even though little bit of whatever hours possible from your side you keep every day. Every day 3 hours, every day 4 hours, every day 5 hours. Efficiently, doesn't matter how much you are keeping. Efficiently, every day keep few hours, whichever possible from your side. If you do continuously, then only it is possible. Supposition that see, right? Yesterday also I taught, today also I taught, right? Assume that every day I am teaching well, right? Then only finally you will say that I am a good teacher. One day teaching very well, next 5 days dancing, there is no meaning in that. Continuously matters, continuously. Yesterday I taught well, today I taught well, tomorrow, every day if I am doing nice work, then only finally you will recognize my efforts. Right? So if I don't do in between, definitely there is no meaning. Growth will always happen continuously. Continuously you should grow. Right? Even though it is a very small number, right? N times multiplied. It is a big number, very root n times only multiplied. If you see the overall, right? I think 2 power n is bigger. Now can you help me now? N factorial bigger first 2. Next 2 power n, it is the 2. Right? Next assume that it is 3. It is 3. Until now, this is the story. If any change is there, afterwards I will do that. Between these 3 people, if I compare, right? One is, right, is the number 1, it is going to be number 2, it is going to be number 3. I am giving, numbers I am giving, right? Bigger one onwards I started. Afterwards, whatever he is asking, we will do. Ascending order only we will go, don't worry. But when you know descending order, what is there in the ascending order? Reverse it, right? Whichever is convenient to you, you do that. I think 3 things I done. That's fine. Now let's go to the next one. This is the log n factorial. This is going to be log n factorial. You know very well. What is the answer of this one? This will goes to n log n. This will goes to n log n. This is going to be root n. This is going to be root n. Can you help me now? Comparing f4 and f6, who is bigger? It is the n log n. This is going to be only root n. Right? I think this one f4 is bigger, f6 is going to be smaller, right? So I think comparing these 2 people is bigger. Afterwards I will give number. Next one. What about n power log n? That is the n log n. This is the n power log n. Everyone know, right? Everyone know n log n. This one n log n, right? N into log n. Isn't that log n is 5? N into 5. But n power log n, n power 5. So comparing f1 and f4, who is bigger? Comparing f1 and f4, who is bigger? F1 is bigger. Right, that is also okay. Next one, log n power log n. Log n power log n. This is going to be log n factorial. Log n fact. Can you help me now? It is the log n factorial, that is the log n power log n. Can you help me now? Log n factorial upper bound what? What is the n factorial upper bound? N power n. More than n factorial, who is bigger? That is called upper bound. Right? N factorial upper bound is n power n. Can you see the log n factorial? Log n factorial upper bound is going to be log n power log n. Upper bound I am saying. Right? Log n power log n. This is the upper bound. It is the actual one is going to be log n power log n. It is the upper bound is log n power log n. So can you help me comparing f5 and f2, who is bigger? I think f2 is bigger. Afterwards maybe f5. Right? Next one. This is a log n factorial. Log n factorial. Log n factorial, what is the upper bound? right? Log n factorial upper bound is going to be log n whole power log n. This is the upper bound. This is the upper bound. When you cannot compare, right, given function directly, at least take closest upper bound. Don't take some big upper bound. Take closest upper bound. You may get some idea. Right? Some idea you will get. Closest upper bound you take. Fine, that is okay. Now can you help me? If you are comfortable, let me ask you one small line now. Right? It is the number 1, it is the number 2, it is the number 3, that is fine. Right? That's fine. Right? Now can you help me one small line now? Log n power log n and n power log n, who is bigger? Log n power log n and n power log n, who is bigger? N power log n. Because here n multiplied log n time, here log n multiplied log n time. Right? This may be the next number. This may be. Let's check here. 3 over, it is the 4. Assume it is the 4. Right? Next one. Let me check here. So please give the answer to me. F2 and F5. Who is bigger? F2, because the log n power log n, the upper bound is log n power log n. It may be 5. Right? It may be 6. Maybe I am saying, if anything difference, definitely within few minutes you will get. Right? Don't worry. Next one. Can you help me? What about log n factorial? Upper bound is going to be log n power log n whole power log n. That is fine. Now can you help me one small line now? You only say, right? So until now fine. What are the numbers? 5 is completed. 5 or 6? 6 completed. It is the 5, it is the 6. Right? Can you help me now? F4 and F7, who is bigger? F4 and F7, who is bigger? What is the F4? F4, if you apply n log n, right? This one is going to be log n whole power log n. Right? Now can you help me now? If you have small doubt also, right? Little bit also doubt there. For these two people, apply log here. Apply log here. What is the answer? If you apply log here, what is the answer? Log n plus log n. Log n plus log n. Means log n. What about if you apply log here? Log n. Log n into log n. It is the log n into log n. It is going to be, right, log n. Log n is there. I think it is bigger. Right? So can you help me one small line now? So F6, I think 6 over, it is a 7. It is a 7. Next one, it is a 7, that's okay. Next one, can you help me now? Root n and log n whole power log n. Who is bigger? Root n one side, log n whole power log n. Then what is the answer? Right? This one, if you apply log here, what is the answer? 1 by 2 log n. This is going to be log n into log n. That is only log n. This is bigger. 7, it is the 8. Right? This is going to be 9. Check once if anything wrong. What is the least one? Log n whole power log n. That is the least. Upper bound I am taken. Still it is smaller. If you apply log here, log n into triple log. If you apply log here, 1 by 2 into log n. Here log n, it is going to be log n into log n. Right? This is bigger. Comparing these two people, what is the answer? This one if you apply the log, right? This one if you see, it is the n log n. This is going to be root n. It is the n log n, it is going to be root n. Right? Please be careful. Here n there, here root n is there. That is the reason it is bigger. So can you help me know who is the number 1? N factorial. Number 2, 2 power n. Number 3, n root n. Number 4, n power log n. Number 5, log n power log n. Number 6, log n factorial. Number 7, n log n. Number 8, root n. Number 9, log n. Log n. If you really okay, let me write now. All these things, let me write in the, right? Let me write in the increasing order. Right? Ascending order, descending order. Ascending order, descending order. Let me write. One new point also there. See, everything cannot be new. One new point also there, it's okay. One point also, one new point also if you get, it's okay. Let me write, because of descending order I written. Let me write descending order. Number 1, who is that? Number 1, right? Number 1, who is that? N factorial. Can I say number 2? 2 power n. Number 3, n power root n. Number 4, n log n. Number 5, log n power log n. Number 6, log n factorial. Number 6 is going to be log n whole factorial. Number 7, who is the number 7? Log n factorial. Number 8, root n. Number 9, log n whole power log n, means log n factorial, right? So these are the numbers, right? 1 2 3 4, 1 2 3 4 5 6 7 8 9, right? So let me write in the reverse order, you can write. This is the thing what you want, right? Ascending order. Let write in the reverse order. First one, log n. Next one, first one is going to be log n factorial, right? Second one, root n. Third one, log n factorial. Fourth one, log n whole factorial. Fifth one, log n power log n. Sixth one, n power log n. Seventh one, n root n. Eighth one, 2 power n. Ninth one, n factorial. Please be careful. It is the ascending order. It is the ascending order, it is the descending order. If you know one order, you know you will get the another one. And one more. Please listen one more small line. Root n, n log n. Root n, n log n. Who is bigger? Root n, n log n. Who is bigger? Everyone know. Here root n there, here n is there. Everyone know this is bigger. Everyone know. Root n there, n log n. One important point I am saying to you. In the previous class also I said. Now also I am saying. This is the serious warning. Otherwise, you may do in the exam. This is wrong. Please be careful. Right? So I am reminding you one more time. Right? One nice suggestion also I am giving. Right? Please listen. It is the root n. It is the n log n. Who is bigger? Right? I think everyone. Here n is there. N log n is bigger. Everyone know. Right? So what some people will do is, it is the root n. It is the n log n. Directly you can say use minimum common sense. Minimum common sense you use. It is the n. It is the root n. It is the n. N log n means n is there. So everyone know n log n is bigger. Right? Fine. Some people what they will do, they don't want to use their brain at all. What they will do is, they will apply log both the sides. Apply log. If you apply log here, what is the answer? 1 by 2 log n. Apply log also. Log n plus log n. Right? I think if you forget about a small thing, it is log n, it is log n. Please see. Both are log n. So it is looking like both as equal. Right? Please be careful. Everyone know in these two people, root n and n log n bigger. Everyone know. If you apply blindly log, this is the problem. Right? This also became log n, this also became log n. Both are looking like equal. Right? So can you help me from this one? What is the conclusion? In examination, in competitive examination especially, right? While solving, which one is smaller, which one is bigger? Please try to avoid using log. Please try to avoid using log. Otherwise, there may be some problem like this. See, both are looking like asymptotically equal. Mathematically, there is a difference. Mathematically, always correct. See this one. I think let me say one mathematical thing. See this one. If a less than b, if you apply log, right? Log a less than log b, no problem at all. But asymptotically, a less than b, after applying the log, asymptotically, there may be a chance of equal, something like that. Please try to avoid using log. Some students are asking, right? Sir, I want to use log. How should I do? Right? If you want to do log, if you want to use log, at least follow this. At least follow this. Through experience, I got to know. At least follow. Try to avoid using log. That is the first condition. Still, if you want to use, right? Then what is the minimum thing you can do is root n here, n log n here. Right? At least simplify first before applying log. Before applying log, don't apply log blindly. If you do blindly anything, right, definitely wrong only. Don't do blindly anything, just use minimum common sense, right? Left is root n, right is going to be n log n. Still, if you want to use log, you can apply. Some people are asking, sir, how? Before going to apply log, common things you cancel. What is the meaning of common? It is the root n only, right? This thing can be written as in terms of this. How? This n can be written as root n into root n, log n, right? Common things first cancel. First cancel the common things, then it will become 1 here. It is going to be root n log n. Now if you want, you can apply log, right? This is greater. Try to avoid applying log first. Still, if you want, you can go ahead. But one thing, simplify first. Simplifying is nothing but, if anything, write 1 in terms of another, common things cancel. Means unnecessary dust will go. Before going to apply log, unnecessary things first cancel. What is the meaning? One function you write in terms of another function, then common things will come, cancel it. Suppose some people are asking, sir, another one I am unable to write in terms of another. If you are unable to write, right, then directly you can apply log. This may be something like this. See this? Something like this. 2 power n power n. See this one? I cannot write. I cannot write 1 in terms of another, right? Then you can apply log directly. If you think that something is common, please cancel it. That is the reason I am giving suggestion also. Try to avoid applying log. Still, if you want, you can do common things cancel. How to cancel common thing? Try to write one function in terms of another function. Then cancel the common things. Still, if you are unable to do that, right? One you are unable to write in terms of another, means not possible maybe. Then you can apply directly log. Right? So you can apply log also, no problem, but use minimum common sense. Right? Fine. So I am thinking that this problem is a nice one which covered many things. Some small confusion is there if anyone thinking, right? Please take care. Right? One new thing also, it's fine. Ascending order, descending order. If you know one order, right, you know other order also. It is the decreasing order. It is the increasing order. Right, fine. Let's go to the next one. Let's see the next one. Many problems I said to you until now, few more problems are pending, right? To complete them, these are required, right? Mostly whatever I am going to say now, you know very well, one time let me write. Properties of asymptotic notation, right? If I want to cover the remaining problem, these are required, which you know very well. The only thing is, systematically I have to write, I will write, right? One time you listen, one time. If anything new, please learn. One time I am writing, please, if anything new, please learn it. See this one, first one, see this one, reflexive property. Reflexive property. Reflexive property. Some people are asking, what is the meaning of reflexive property? Let me check here. Let me check. See this one. Is it right or not? F of n is equal to big O of f of n. Is it right or wrong? That is the meaning of reflection. Both the sides same. Left whatever there, right also same. If you see your face in mirror, you will see your face only. Means reflection. So, reflexive property means both the sides same thing there. Big O satisfied or not? Please check. F of n is big O of f of n. Is it satisfied or not? Of course. N square is big O of n square because less than or equal to equal there. But I think it is satisfied. Right? N square is big O of n square. N cube is big O of n cube. You know very well. So, I think reflexive property big O satisfied. Can you say what about omega? Right? What about f of n is omega of f of n. Is it satisfied or not? Of course, greater than or equal to theta. Theta means equal. Yes, definitely satisfied. Small o, no chance. Small omega, no chance. Let me write now. Reflexive property, big O pass, omega pass, theta pass. These three people pass. Right? Small o fail. Small omega also fail. It is a small o. Right? It is a big O. That's fine. So, reflexive property, right? Big O, omega, theta satisfied. Remaining things fail. Reflection means both the sides same. Right? Let's see the one more. Symmetric property. Symmetric property. What is the meaning? I will explain to you. Symmetric property. Like symmetric matrix. See this one? What is the meaning of symmetric property? If f of n is big O of g of n, if f of n is big O of g of n, then g of n is big O of f of n. That is the meaning of symmetric. Symmetric property means if A is equal to B, then B is equal to A, something like that. That is the meaning of symmetric. A is equal to A transpose. That is the meaning of symmetric matrix. Right? It is something reversing kind of thing. Right? Now can you help if f of n is big O of g of n, true, assume if it is true, then g of n is big O of f of n. Is it true or false? Right? I think there is no meaning of this. Right? So what is the meaning of this one? Comparing f and g, if someone say g is bigger, then how can I say f is bigger? First statement saying that if g bigger, second saying that then f bigger. There is no meaning in that. Between f and g bigger, then how can I say then f bigger? There is no meaning. So symmetric property big O don't satisfy. See this one, big O don't satisfy. Right? Otherwise, best way of writing is this one. If f of n is big O of g of n, then g of n is big O of f of n. Need not be. If this is true, from this I cannot conclude this. Need not be true. Sometimes may be true. What is the meaning of true? Every time true. That is the power of the truth. If you are an honest person, you go anywhere, you will survive. Sometimes true, sometimes false. No, it is not like that. Honest statement, it is the true statement. Everywhere true. One case fail only. Right? Fine. See this one, if f of n is big O of g of n, then g of n is big O of f of n, need not be. So symmetric property big O fail. What about omega? Same. But what about theta? Theta pass. What is the reason? If f of n is equal to theta of g of n, then g of n is theta. Theta means equal. Equal people, any side will be equal. N square is equal to n square, reverse. N square is equal to n square. Big O fail, why? N square is big O of n cube. N cube is big O of n square, no. So big O fail, omega fail, symmetric property, theta pass. I think now people got to know. Sir, big O fail, how can you say theta pass? Omega fail, how can you say theta pass? That is the reason I said to you, don't buy heart. If you buy heart, somewhere you will trouble. Right? Definition of the big O, definition of theta saying that big O omega satisfied, then theta will be satisfied. That is the normal definition of the theta notation. Everyone know. But see here conditional. What is the meaning? If the first one true, second true or not, you have to verify. If the first one is true, second true or not. If the first one is true for theta, means if both are equal, reverse also true. So big O fail symmetric, omega also fail, but theta pass. Let me write now. Big O fail. See this one, big O fail. Omega also fail. Next, what about small O? Small O guarantee fail. Small omega fail. These four people fail. Only one person theta pass. That is the meaning of symmetric property. Right? So these four people fail. Right? Theta pass. Reflexive property, symmetric property. Right? Now see the next one. Many people know this. Right? Only for name. They kept the names and they written. It is better to write one time. That is the reason I written. Right? Fine. Now see this also. Transitive property. Transitive property. Some people are asking what is the meaning of transitive property. Many people know. Let me remind you one time. Let me remind you. See this one. If f of n is equal to big O of g of n, if f of n is equal to big O of g of n and g of n is equal to big O of h of n, then f of n is big O of h of n. If f of n is big O of g of n and g of n is big O of h of n, then f of n is big O of h of n. This is the meaning of transitive property. This is the meaning of transitive property. Right? Let's verify. Is it right or wrong? F of comparing f g bigger, comparing g h bigger, then comparing f h bigger, of course. Right? If anyone having small doubt also, take one example and check this one. N square, compare n square is less than or equal to n cube. N cube is less than or equal to n power 4. Then, right? Definitely n square is less than or equal to n power 4. True. I think big O satisfied. Reverse it. Omega also satisfied. Then theta also satisfied. Why theta is satisfied? Let me check here. N square is theta of n square. Next one, n square is theta of n square. Then n square is theta of n square. Right? I think big O satisfied, omega satisfied, theta also satisfied. What about small O? I think it is small O only. N square less than or equal to n cube. right? Equal remove. N square less than n cube less than n power 4, n square less than n power 4. I think small o also, small omega also. Means what happens? Big O pass, omega pass, theta pass, small o pass, small omega, all pass. All pass. Please remember, in exam they may ask you which one of the property satisfied by all these 5 people. I think transitive. Please check if any case fail. It is something like this one, right? A and B friends, B and C friends, and A and C friends. Something like common friend. A and B friends, B and C also friend. Then A and C becomes friends. Something like that, right? In real life, it may not be true, but right, in the asymptotic notation, transitive property pass. All these 5 people are passing. Right? Take care. Until now, fine. Right? Let's see one more case. See this also. See the interesting one more. See the answer. If f of n is big O of g of n, if f of n is big O of g of n and d of n is big O of e of n, if f of n is big O of g of n and d of n is big O of e of n, assume that these are the 2 statements which given. Right? This is also true, this is also true. Assume. What is the meaning of this one? What is the first statement saying? Comparing f, g bigger or equal also. Comparing f, g bigger. Assume. Comparing d, e bigger. For the f, upper bound is g. For the d, upper bound is e. What is the meaning of upper bound? Greater or equal. You know this very well. Right? Comparing for the f, g upper bound. For the d, e upper bound. Then see the interesting answer. Then for the f, upper bound is g. For the d, upper bound is e. Then can you help me now? For the f and d combinedly, what will be the upper bound? For the f, upper bound is g. For the d, upper bound is e. That's okay. Right? For these 2 people combinedly, who is the upper bound? I know individually I know. For the f, g upper bound. For the d, e upper bound. Combinedly, who is the upper bound? Can you help me now? Combinedly, who is upper bound? If I want to say, can I say g is upper bound? Combinedly, g is upper bound. If I write combinedly, g is upper bound, f is okay, d is not okay. If I say combinedly, e is the upper bound, if I write, d is okay, but f not okay. Then what is the answer? Best answer. This is the best answer for this one. Combinedly for f and d, upper bound is going to be, this is the answer. See this one? G of n, e of n. These two people you take, right? Find maximum of these 2. Find max. These 2 people. So for the f upper bound is g. For the d upper bound is e. Both the upper bounds you take the maximum, right? To that big O. Right? Whichever is the bigger out of those upper bounds you take, right? Maximum, that maximum will come big O. Of course, it is going to be pass. Now, can you help me one small line now? Can I write omega also? It is a big O only. Here also big O. Right? Here also big O. Right? Please be careful. Both the upper bounds you take maximum, then big O. This is the answer for this. Now again I am repeating now. F upper bound g, d upper bound e, f and d combinedly which is the upper bound? If I take only g, d having problem. If I take only e, f having problem. Best idea. Take both the upper bounds maximum to that big O. Right? Fine. Now see the next one. One more interesting answer. See the one more interesting. This is the 1 point you have to learn. Right? For this one, this is the first point. Please remember it is a nice point 2. See the second point. F upper bound g, d upper bound e, it's okay. Then what about this one? F of n into d of n. What is the answer? F of n into d of n, then answer is going to be, alright. So I think f upper bound is g, d upper bound is e. If you multiply the left side people, right hand side people also multiply. G of n into e of n. Big O. Right? That is the answer. Omega also you take care, right? Big O I explained, omega also you take. It is a very, very important point. If f of n is big O of g of n, d of n is big O of e of n, then f of n plus d of n. What is the meaning? Left people if we add. What about right people? What is the answer? Right people, just to take the whichever is the maximum, right, to that big O. Next one, left people if you multiply, right people also multiply. Some people are asking, sir, if I don't do like this one, if you don't do like this one, sometimes maybe fail. If you want always correct answer, left multiply, then multiply right also. Then always correct will come. Two small things if you multiply, it may become little bit big, then multiply two bigger also, they will become more big. If you take only one, two left side people are smaller, big O notation, right hand side people are bigger, two smaller you multiplied, right? Then two bigger also multiply, definitely big O will work out. Suppose two smaller multiplied, it became little bit big. Then if you take only upper bound 1%, it may not satisfy sometimes. Best idea to satisfy every time. Left multiply, multiply right also. Right? Fine. So I think 4 points I set you until now. See this one? I think reflexive property, symmetric property, transitive property. Right? This one is going to be. Right? So I think to this one there is no name, but this is the nice one. Comparing f, g bigger, comparing d, e bigger, then right left side if we add, right side also add. What is the meaning of right side also add? Take maximum. Left side if you add, right also add. Everyone adding is nothing but taking maximum. Right? To that one big O. Left if you multiply, right also multiply. Right? These are the 4 points. Please remember, no need to by heart. Right? Meaningfully study one time. Problem. The basics which are required for this problem, those are properties of asymptotic notation. We are already done. Right? Now read it. You may get more clarity. That is the reason after those basics over, I started this problem. Right? Check this. Let f of n, g of n and h of n be three positive functions defined as follows. Right? Three functions, they defined like this. Right? Some story given. Three functions are defined like this, right, which are given in the statement 1, statement 2, right, they defined like this. Next one, after this, see what they are asking. From the above data means from this, check following statements are true or false. Some data is given, based on that, verify these given statements are right or wrong, right, we will see now. What data is given, what is the conclusion we can give, we will see now, right, fine. So read the first statement. F of n is big O of g of n, g of n is not big O of f of n. These are the two statements. Right? In first line only two statements are there. Second line also two more statements. Now can you help? Let's go. Totally 4 statements, they written in 2 lines. Right? Let's see the first line. Can you help? F of n is big O of g of n. What is the meaning? G of n may be bigger or equal. Can you help? Right? This one. F of n is big O of g of n. G of n may be bigger or equal. What is the confusion you have? G of n may be bigger or may be equal. But one thing, f of n cannot be bigger. F of n cannot be bigger. Right? Can you help? From this, what can you conclude? Either g of n bigger or equal. Only two cases are arrived. G of n may be bigger or equal. Right? Fine. Let's see the interesting answer. Suppose isn't that f of n is big O of g of n means g of n is bigger or equal, it's okay. Suppose isn't that reverse also possible. What is the meaning? F of n is bigger or equal also true. Assume means equal. Because you know very well either g of n bigger or equal, only 2 choices. Reverse also possible. What is the meaning? I think both are equal. Both are equal because less than or equal. If equal, they are both the side true. F of n is big O of g of n, g of n is big O of f of n, if both equal. If both, right, let me ask you, g of n may be bigger or equal, right, reverse also true, then both are equal. If reverse not true, it is less than. I am in dilemma, is it less than or equal? Less than or equal, some dilemma. See this one, reverse not possible, g of n is not order of f of n, reverse not possible. What is the meaning? If reverse also possible, it could have been equal, because of reverse not possible, it is less than. It is less than. What is the meaning? F of n is less than g of n. Actually, because the first one is true, f of n is less than or equal to g of n. Reverse not true, means equal, no chance. Then f of n is less than g of n. A is big O of B, B is big O of A. Then A is equal to B. Because of asymptotically equal. But here A is big O of B true, B is big O of A is false. Indication that, right? Theta not possible. Means it is less than or equal to. What is the meaning? Previously less than or equal to, when you got to know that theta not possible, equal gone, means less than. Actually what I want to say, you could have said this story, small o. F of n is small o of g of n. You could have said, instead of saying that, indirectly said. What is that one? Big O possible, This means omega not possible. This is the indirect way of saying omega not possible. Big O possible, omega not possible means theta not there. Big O possible means less than or equal to. Omega not possible means theta not there. Theta not there means equal not there. Means it is going to be less than, means small o. You know this very well. Fine. Let's come to the next one. G of n is big O of h of n. What is the meaning? H of n will be bigger or equal. Reverse also possible. See this one. Reverse also possible. What is the meaning? Conclusion from these two. Right? G of n is equal to h of n. Reverse possible means equal. Reverse not possible means either less than or, because of big O less than or equal to. Reverse not possible means equal not possible means less than. Now here reverse also possible, equal. Right? Can you say what is the final conclusion? See the final conclusion. Fn is less than Gn, right, and Hn, which are both are equal. Right, fine. This is the conclusion. Can you help me now? Total statements how many? 4. How many lines he written? 2. Can you say final conclusion? F of n is less than G of n and H of n, which are equal. This is the final conclusion. From that, right, see this one. From the above data, check the following statements are true or false. From the above data, check the following statements are true or false. We have to verify. Can I say given three functions f, g, h, right? Out of these 3, what is the relation? What is the relation between all these three people? Fn less than Gn, which is equal to Hn. This is the relation. Now check one by one. Can you help me now? Fn plus Gn, which is bigger? Gn bigger. Fn plus Gn is bigger. Right? Is big O of h of n. Everyone knows Gn and h of n. Even though you are done the plus, right? Larger one will come into the picture. Fn plus Gn is bigger. Gn is big O of Hn. I think Gn and Hn both are equal. That is the reason big O possible. Can you help in option A? Big O is true or not? Yes. Can you say option A? What is the left side? Gn bigger. Right side Hn. Gn is big O of h of n. True or not? Yes. Can you help in option A? Omega. Yes. Because left and right, both the side greater person is equal. In the option A, if you observe, left side, right side, bigger function is equal. So, big O possible, omega possible, theta possible. Small o no chance, small omega no chance. Everyone know that. Let's go to the option B. F of n is small o of h of n. It is small o. Until unless I will read small o, right? Consider it as all are big O's only. If you have small doubt, it is a big O or small o. If I say small o, then only consider. Right? So, normally big O only. Because in the examination also, normally big O's only they will give. That is, normally I don't write small o. If I say small o, maybe I want to explain to you. Other than this, nothing. Can I help you now? Option B. F of n is small o of h of n. What is the meaning? Right hand side. Option B saying that right hand side strictly greater comparing with the left hand side. Of course, f of n is smaller, h of n is bigger. True. Small o true. Small o true means big O also true. Small o true means big O also true. Big O true doesn't mean that small o. Right? Fine. B also fine. Let's go to the option C. See this one? H of n into G of n. H of n into G of n. Can you help me now? These two people are smaller people or greater people? See, these two are equal, right? Greater. Two greaters are multiplied. Left hand side, two greaters are multiplied. Right hand side, two greaters are multiplied. Theta definitely. See this one, even though these two are different, but both are equal value. H of n into G of n, which is equal to H of n into H of n. Theta possible. Let's go to the option D now. See this one, option D. One smaller, one bigger multiplied. But here, right, two biggers multiplied. Here one smaller, one bigger multiplied. But here two biggers multiplied. So actually it is a big O. Right? Actually it is a big O or small O. Actually it is a small O means big O also. There is no chance of omega. So that is the reason option D false. Option D. Right hand side is more comparing with the left side. So actually small O means big O also. There is no chance of omega. So theta fail. So here option should be, right, small o and big O. Right? Theta not possible. So can you help He is asking check following statements are true or false. I think first 3 statements are true, last one is false. Can you help last one is true when, right? If at all big O true, small o also true, right? I think remaining will be failed. So 4 statements are given from the first 2 statement conclusion Fn less than Gn. Can you say what is the simple way of saying, right? First line, simple way of saying first line is Fn is small o of G of n. First line simple way of writing Fn is small o of G of n. Instead of that, he said that big O possible, omega not possible, means theta not possible. Theta not possible means equal not there. So less than or equal to, only less than. Here less than or equal to, reverse not possible means theta not there, means equal not there, so less than. Here reverse also possible, so equal. Final conclusion, Fn is less than Gn, which is equal to Hn. Right? I think these things you can easily handle. So answer for this problem is first 3 statements are true, last one is false. Right. I am thinking that most probably everyone got. Small doubt also there, please take care. Suppose assume that it is equal, then what happened? Then all 3 people will become equal. Then answers, if you see, left one person, right one person, big O, right. Next one, here because of all are equal, small omega no chance. I think option B fail. Option C pass, option D pass. If I remove here not equal, then all will become equal. Then answers are going to be A true, C also true, D also true, this will fail. Because small o means what is the meaning? Hn is strictly greater, no, all are equal. For the given problem, A, B, C true, D false. Suppose if I remove this not equal, if I made it as equal, then A true, B false, C true, D true. Right? Fine. I'm thinking you are okay. Let's go to the next problem. Right, see this problem also. I am also reading. Let f of n, comma t1 of n and t2 of n be 3 functions defined as follows. Mean 3 functions are there, fn, t1 of n, t2 of n, which are defined as follows. So like previous problem, this also. 3 functions are there, fn, t1 of n, t2 of n. These are defined like this. How they are defined? Let me check. T1 of n is big O of f of n. T2 of n is big O of f of n. What is the meaning? T1 upper bound is f of n. T2 upper bound is f of n. What is the meaning? For these 2 people, common upper bound is f of n. I am repeating once again. T1 upper bound f of n. T2 upper bound f of n. What is the meaning of upper bound? F of n may be greater or equal. Comparing T1, f of n may be greater or equal. Comparing T2, f of n may be greater or equal. Right? It is a given one. Now see the next story. From the above data, check the following statements are true or false. So some data is given, they are asking from the given data, check the following statements are true or false. What are the given data? Comparing T1, f of n may be greater or equal. Comparing T2, f of n may be greater or equal. This is the only information given. 2 statements are given. From that you have to conclude something. Right? Whatever you got from those 2 statements, right? So you have to verify in the available option which is true. Right? I am thinking you are a little bit fine now. Let me ask you. Comparing T1, what is the answer? F of n may be greater or equal. Comparing T2, f of n may be greater or equal. That's fine now. Right? That's fine now. Right? Now see the answers. See the answer. Can you help T1 upper bound is f of n, T2 upper bound is f of n, it's okay. But if you add both the things, T1, T2, what will happen? If you add these two also. Right? For these 2, upper bounds are going to be these 2, just add. If you add the left side people, add right side people also. If you take only one problem will come. So see this one, left you add it, right also add. If you add right hand side, f of n plus f of n, f of n. So true statement. Left hand side if you add right hand side also. Right hand side f of n plus f of n, which is nothing but f of n. Right? I think option A is true. Now see the next one, option B. T1 of n plus T2 of n is omega of f of n. You only say T1 upper bound is f of n, T2 upper bound is f of n. How can I say T1 plus T2 upper bound is omega of f of n? There is no meaning. It never be possible. Suppose some people are asking me, what about option B? Right. So what about option B? Option A fine. What about option B? Let me check. T1 of n plus T2 of n is omega of f of n. You only say comparing T1 of n, f of n bigger, comparing T2 of n, f of n bigger. Then for this one is upper bound, for the T2 it is upper bound, for the T1 and T2, how can I say that suddenly this is going to be right, this side is going to be bigger, right? It's not correct. It is not correct, right? After taking these two, right, you have to take this. I think option A true, option B false. One case fail only. If anyone saying that this may be pass sometime, sometimes pass is not pass. Every time pass. This is every time pass. Option A every time pass. Option B may fail sometimes. Right? May fail sometimes. Please be careful. If you want, you can check this one. See this one. If you want, you can check. N power 5 is big O of n power 10. Next one, right? Next one. N power 6. It is n power 10. Right? If you add left side, n power 5, n power 6 is omega of n power 10. There is no meaning. Right? This side cannot be greater. Sometimes maybe whenever equal it may be possible. One fail only. So option B fail. Option A pass every time. Can you say what is the option C? T1 of n is theta of T2 of n. He is saying that T1 and T2 both are equal. Need not be. There is no relation at all. Need not be. It may be 1 or 2 times true, but no relation. Next one, T1 and T2 is bigger, maybe, may not. In this problem, maybe, right? If I do reverse, it is n power 6, it is n power 5, right? Need not. No relation at all, because it is not mentioned in the problem. In the problem, always is mentioned T1 to F, what is the relation? T2 to F, what is the relation? T1 and T2, what is the relation? Nowhere is mentioned. Nowhere is mentioned T1, T2, what is the relation? So, C and D cannot be the answer. C and D is wrong statements. Next one, what the B saying is, right? So, individually big O, after combining omega possible, no. So, option A is the correct answer. So, can you help me to this problem? Which are true statement? A true. Wrong statement? B, C, D wrong. One case fail only. Fine, I am thinking you got this also. Now, can you help me now? What is the answer of this problem if I do like this? What is the answer of this problem if I do like, assume that T1 of n is theta of f of n, T2 of n is theta of f of n, assume, this is a given problem. What is the answer? Let's check here. T1 of n is theta of f of n, T2 of n is theta of f of n. What is the meaning? Indication that all three equal. T1, T2, right, f of n equal. So, if at all three not equal, right, these two equal, what is the meaning? These two equal means compulsory, these two will be equal, then all are equal. Then what is the option A? Option A true. What is the option B? True. What is the option C? True. What is the option D? True. So, if I make these two as theta, then all are true. If I make this as big O, only A true. Right? So, big O, if I make given problem as it is, big O only, then, right, only A correct. Given one is T1 of n is theta of f of n, T2 of n is theta of f of n. If I write theta, right, then all correct. All correct. Given one is big O's, then only A correct. You are okay now. You are okay. Fine. Let's go to the next problem. See this problem also. See this problem. Let f of n is equal to omega of n, g of n is equal to big O of n, h of n is equal to theta of n. It is a given data. Then f of n into g of n plus h of n is equal to what? So, this gap you have to fill, right? So, what is the answer for this? Let me check. Can you help me now? F of n is omega of n. Can you say what is the meaning of this? The meaning of this one is going to be left will be either greater or equal. Omega means left will be either greater or equal. Can you help me know what the minimum? The meaning of this line is going to be left will be bigger or equal. What is the minimum value expecting? Minimum n here. Minimum n. Can you help me now? G of n is big O of n means who is bigger? G of n is big O of n means who is bigger? Right? Bigger is going to be right side. Bigger is going to be right side. Here these people are going to be, right? What about this person? This may be, I think, constant complexity. This may be constant complexity, whatever it may be. Right? To this one, it is upper bound. Can you say what are the possibilities here? possibilities are less than n or equal to n. The possibilities here less than n or equal to n. Less than n or equal to n, right? Please be careful. So here what is the possibility here? N or more than n. The possibility here n or more than n. Here what is the answer? N or less than n. It is going to be here n or more than n. It is going to be n or less than n. Less than n. That is okay. Here equal. One person is saying that n or more than n. One person is saying that n or less than n. One person is saying that equal to n. These are the three things. Right? Now let's write that. Let's write the minimum things, whatever. I think here n or more than n. Minimum n. This is n or less than n. This may be 1 also. This may be 1 also. Right? This is what is the answer? N. Right? This may be, right? This may be, this is n. Now can help in what is the answer? Sometimes what happened is this is n, it's okay. Sometimes what happened is this is also maybe n squared. Right? Sometimes what happened is, this may be n power 10. Now can you help in what answer you want to write here? This may be sometimes n power 1 lakh also. This is n, this is n, this is always n. I think here it maybe keep on increasing, decreasing like that. Right? So this is going to be, n. This is going to be n, that is fine. Right? Here minimum n will come, but here it is keep on changing. This may be n power 1 lakh also. From this area, is there any chance of, chance of n square? Right? Here may be n square, here 1. Is there any chance of, in the, right, from these people, 1 may come. I think this may be, this is n, this may be, I think, because of is not mentioned anything and all, right? And other than negative, you can take anything. G of n may be 1 by n. If I take 1 by n, n cancel. May be the case, but one thing here, n confirm. Minimum n will be there from this side. Is there any chance of more than n? Let me check. Here n possible. Here, is there any chance of more than n? Let me verify. N here, n, there may be. Next one, here may be n square, it is 1. Here may be n cube and it is 1. Right? I think n here, guarantee more than n coming from this side. 1 also may be come from this area, but one thing here n is there. So, I think I can confirm that omega of n. What is the meaning? Omega of n means this side will be either n will come or more than n will come. You may say that, sir, this place may be 1 possible. This place may be 1 possible. What is the f of n may be n. G of n may be 1 by n. Both may be cancelled. 1 is possible, it's okay, but here n is there. This is n is there. So, minimum n guarantee more than n. This area can give more than n also. This area can give more than n also. That is the reason. Minimum n guarantee. Minimum n guarantee. Can I write this area big O of n? Can I write this area big O of n? If you write big O of n, what is the meaning? Comparing left and right, right will be greater. Means n. No, sometimes it may be n squared. Fail. Is there any chance of theta of n? Theta means always equal. No, this may be n squared. So, answer is going to be this. Right? I think this one, see this one. I am not saying that increasing function, I am not saying decrease. He is not mentioned anything in the problem. He is not mentioned anything in the problem. See this one. F of n is omega of n. What is the meaning? F of n will be either n or more than n. G of n is big O of n. What is the meaning? G of n will be either n or less than n. H of n is equal to theta of n. These are the only things what he mentioned. So, and one more, as I mentioned to you, algorithm starting, what is the answer? Only positive functions we are discussing. This may be n, this may be 1 by n possible maybe. So, n cancel, 1 is there in this area, but from this side n is coming. So, minimum n guarantee. Right? To this problem answer, minimum n. Omega of n means either n or more than n. Left hand side is either n or more than n. So, answer is going to be omega of n. Big O no chance, theta no chance, because sometimes fail. That is the reason. So, to this problem answer, omega of n. Let's see this problem also. Find true statement from the following. Find true statements from the following. Right? 4 statements are given. True statement you have to find out. Let's see the option A. If f of n is big O of g of n, then g of n is big O of f of n. True or false? If f of n is big O of g of n, then g of n is big O of f of n. Is it true or false? Need not be. What is the reason? You only say n square is order of n cube. How can you say reverse possible? Right? This need not be. That is the reason option A failed. Next one, what is the option B? It is really interesting. Please you take care. This will really trouble you. The purpose of giving this problem I am explaining. If I don't say you, it may be trouble you. Right? Listen this. Listen. F of n. Option B, see the option B. F of n plus big O of f of n is equal to theta of f of n. F of n plus big O of f of n is equal to theta of f of n. Right? So, what is the answer of this one? Let me check. Can you help me now? Here f of n is there, it's okay. See the option B, interesting one. Here f of n is there, it's okay. Can you help me one small n now? Right? The place what is written here, f of n, can you say, is it upper bound or lower bound or actual? I'm very clearly writing. See, so the thing which I rounded. Is it this f of n is upper bound or lower bound or actual? See this one, no big O, no omega. Indication that it is actual. Whatever is there, same thing written. It is f of n only. It is not upper bound, it is not lower bound. It is the actual as it is f of n. But here, big O of f of n. What is the meaning? Here there is one actual person. To him it is upper bound. Can you help me now? First place what is written? Actual f of n. Second place what is written is upper bound is written. Can you help me? What is the upper bound? Second place, whoever is there, to him upper bound is f of n. Big O means upper bound. To him upper bound is f of n. If the actual person upper bound is f of n, who is the actual? Actual should be either fn or less than fn. Can you help me now? Who is there in this area? In this area, I written upper bound, but actual person who is there, right? Either fn or less than fn. This is fn confirm. But this area, either fn or less than fn, because it is upper bound. It is upper bound. Right? Please be careful. Let me ask you one small interesting line. N factorial is actual. What is the upper bound? N power n. Right? So if someone asks me what is the actual? N factorial. Actual is n factorial only. Upper bound is n power n. Please be careful. If I ask you what is the actual, you cannot say n power n. Actual is n factorial. Right? Some people will say actual, some people will say upper bound. But right, remember, when you are comparing actuals only, you have to take care. Some people may say upper bound. Right? Fine. Now see this one. Here actual is given. What is that one? Fn. Here actual is there, but to that upper bound is Fn. Can you help me? Who is the actual here? Here actual is either Fn or less than Fn. Upper bound is Fn means actual should be either Fn or less than Fn because of big O. So it is Fn. Here actual is going to be Fn or less than Fn. Right? If I take big also Fn plus Fn, theta of Fn. So true. Option B is true. So try to remember this one. Don't take the upper bound. Right? Actual, always you have to consider actual person only. Always in this area, instead of giving actual, they give an upper bound. So actual persons only you have to compare. F of n plus, here actual is going to be Fn or less than Fn. So if you take larger also, Fn plus Fn, theta of Fn. Right? I think if anyone thinking that, small doubt also there. Right? I think option C will give more clarity. Let me check. Can you help me now? Here actual Fn. But here upper bound given. Can you say which upper bound it is? Small o. What is the meaning? Strict upper bound. Can you help me now? What is the strict upper bound? Fn. If strict upper bound is Fn means, who is the actual here? Right? I am repeating once again. If the strict upper bound is Fn, actual person is less than Fn. Actuals only you have to consider always. Actual only. Some people will say upper bound, but actual only how to compare. F of n plus, what is the answer? Strict upper bound is Fn. Means here actual person is less than Fn. Fn plus less than Fn, then Fn. Fn plus less than Fn. Can you help me now? N square plus less than n square. Right? N square. Here see this one. Here. Can you help me one small one? Assume that Fn is n square. Assume that Fn is n square. Assume that. Right? Here it is going to be. I am repeating once again. Assume that Fn is n square. See this story. Assume that Fn is n square. Assume. If Fn is n square, see what he written? N square n square. Here actually n is there, but he written small o of n square. This n can be written as small o of n square. Everyone know? Yes, right? So here Fn, strict upper bound is Fn, means actual person here less than Fn. So Fn plus less than Fn, overall is Fn. Fn is theta of Fn, true. Please be careful. Fn is n square, here n square. Here n means its strict upper bound is small o of n square. Actually is n only. Right? Fine. So that is the option C, which is true. Let's go to the option D, which may give some more clarity. Can you help me now? How many people will go? Small o of Fn, what is the meaning? Small o of n, what is the meaning? The person who is there in this area, right? The person who is there in this small o of n, the person who is there in this area, this is the strict upper bound. The actual person should be less than n, that may be log n. Less than n, that may be log n. That may be 1, that may be 1 by n, but one thing is true. Whatever is there in this area, to that strict upper bound is n, means the actual person may be log n, right? May be log n, may be constant, right? May be, right, 1 by n, anything may be possible, right? Strict upper bound is n means the actual person here less than n. Next one more thing. Here, see this one, strict lower bound is n. Strict lower bound is n. Can you say who are the possibilities here? Maybe n square, maybe n log n, maybe n log n. Here it is going to be, right, here the person who is there, strict lower bound is n. Strict lower bound is n, indication that, right, actual people are more than n, maybe n square, n log n, right, n log n, like that. But it is going to be n. It is always n. It is always n. Can you help me now? Right, here what are the possibilities? Maybe log n, maybe 1, anything possible. Here n square, n log n, log n, right? Next one it is going to be n, right? Now can you help me one small line now, right? So what is the minimum here? 1 also, 1 by n also. Now can you help me? What is the minimum here? What is the answer? More than n required. This area saying that actually is more than n, because strict lower bound. Strict lower bound is n means, right, actual things are going to be more than n here. It is exactly n. Here 1 also possible. Can you say overall? What is the answer? Overall, if you see this one, omega of n. What is the meaning? Omega means, right, greater than or equal to. Means n is saying no. Here more than n possible. Here actual value less than n. Here actual value more than n. Here actual value equal to n. Overall, if you see, what is the answer? Omega of n is false. It is actually, right, small omega of n. Minimum n will be there. Minimum n. I think strict lower bound is n. Lower bound is not n, because this omega saying that equal n also. No, it is saying that always I want more than n. He is saying more than n. He is saying less than n. He is saying equal n. Overall, if you observe, right, more than n required. So I think it is omega of n. But he is given big omega of n. That is the reason false. Suppose if at all here isn't that, here n only there. Here I think it is more than n required. That is the reason fail. Right. Let's see this one. This is saying that, right, strictly less than n. This is saying that strictly more than n. This is saying that exactly n. Then can you help me now? What are the possibilities in this area? What are the possibilities? What are the possibilities here? I think this is going to be less than n, this is going to be more than n, this is going to be equal to n. Overall observation, if you see, more than n. So what is the answer here? Answer is going to be, what is the answer? This area is more than n. I think this is going to be omega of n. Omega means, everyone know, small omega. What is the meaning? Small omega means left hand side is going to be more than n. Yes, true. Whenever you say small o satisfied, right? I think whenever you say small omega satisfied, big omega also will satisfy. Big omega also satisfied. I think it is actually small omega, big omega also will satisfy. He is saying that less than n, he is saying that more than n, he is saying that equal to n. Overall, if you observe, more than n, right, more than. See, everyone, omega means what? This side greater. Actually it is a small omega. Actually it is a small omega, right? Because this side is strictly greater. When you say small satisfied, big also will satisfy. I think answer is going to be option D also true. Can you help in option A? False. Option B true. Option C true. Option D true. Small omega satisfied means big omega also will satisfy. There is no meaning of small omega satisfied, big omega not satisfied. There is no meaning. Small omega means greater than or equal. Small omega means greater than. Big omega means greater than or equal. When subset satisfy, superset guarantee will satisfy. It is a nice problem. Please you take care. Now I think from today onwards I want to say one small thing to you. Please listen. Please listen. Big O of n power n. What is the meaning? Big O of n power n means is the actual one or upper bound? Upper bound. What is the actual? Actual is going to be either n power n or less than that. That is the meaning of big O. Big O means what? Upper bound is n power n. Actual person should be, left hand side person should be either n power n or less than n. Less than n power n. Actual person should be either n power n or less than n power n. That is the meaning of upper bound. Actual person is means left hand side person here. Actual person means this left hand side person should be either n power n or less than that. Okay, can you help me now? Can you help me now? Small o of n. What is the meaning? Strict upper bound is n. Means actual people less than n. Confirm. Next one. Strict lower bound is n. Indication that. Right? Minimum n is there. What are the actual people? Right? More than n will be there. More than n. This is going to be theta exactly. So, it is less than n, it is more than n, it is equal to n, overall is going to be more than n. Right? This is. Right? Whenever small omega satisfied, big omega also will satisfy. So, answer is going to be B, C, D true, A is false. Nice problem, please take care. Until now we completed, right, analysis part, that is the time complexity, space complexity pending, we will see that. Next one, one topic I completed analysis, that is the time complexity finding. One more is going to be asymptotic analysis, big O, omega, theta. Right, time complexity purpose maybe I said approximately 20 problem. Right, next one, asymptotic analysis also I said 20 more problem. Right, please be careful with those two topics. Right, algorithm subject you study topic wise. Right, don't study entire algorithm subject and all. Right, study topic wise. First topic, are you comfortable or not? Second topic, you are comfortable or not, like that you do. When you do topic wise justification, you will do the entire subject justification also. You don't say at anywhere algorithm subject I am not fine. Algorithm subject I am not fine, don't say. Say which topic you are not fine. When while asking your friend also, right, algorithm subject topic number 15, right, problem number 7 I am not okay. Can you explain? If you do that, if you ask like that, definitely every friend will help you. When you ask meaningful doubt, right, definitely friends will help you. Some people what they will do is, they will blackmail the friendship. What they will do is, can you explain the algorithm subject if you are really my friend? If you are really my friend, explain algorithm. Who will explain total algorithm subject? Right, there is a limitations for everything. You cannot blackmail your friendship. You cannot misuse your friendship. Because of that reason, so many friendships are gone. Many friendships will broken, right, because of these reasons only. If you are really my friend, can you explain the total GATE syllabus? There is no meaning in that. Right? If you want to save your right friendship and all, ask in the nice way. What is that? In algorithm subject, I am okay with everything. But in the topic 15, question number 7, I have doubt. Can you explain? Topic 10, question number 2, I have some doubt. Can you explain? If you do that, everyone will help you. Even unknown person also can help you if you ask the nice thing. Even known person also, they may not help you if you do some nonsense. Who will explain the entire algorithm subject? Who will explain the entire GATE syllabus? There is a limitations for everything. If anyone explain the entire GATE syllabus to you, that means, right, he is nonsense, you are also nonsense. Right? Please you take care. Right? Do meaningful things, right? Everyone will support you. Until now, 2 topics I covered. Right? Time complexity finding is the first topic. Second one is going to be asymptotic notation. Now see the third one. See the third one, main thing is starting now. Everything is main in algorithm subject. One thing also you cannot leave. There is some relation between every topic. Right? Fine. So let's see the next topic. Third topic maybe. See this one. Basics of divide and conquer. You actually thought, right, divide and conquer is the next chapter, right? But divide and conquer, if I want to say, divide and conquer basics I have to say. Without completing the basics of divide and conquer, we cannot go to the divide and conquer. So, what is the topic name? Basics of divide and conquer. Right? That is the right. So, that is the next topic. Maybe you can say third topic. Basics of divide and conquer. Not divide and conquer, basics of divide and conquer. After this, divide and conquer will start. So, some people are asking, sir, what is the basics of divide and conquer? What are those? Recursion, recurrence relation, solving. Recursion, recurrence relation, solving, which internally contain recurrence relation solving three methods: substitution method, recursive tree method, master theorem. Right? Master theorem. So, recursion is the first one, recurrence relation is the next one, recurrence relation solving is the next one. Right? So, first two things are over, recurrence relation will come. Right? Recurrence relation solving contain, right, three methods: substitution method, recursive tree method, master theorem. Right? Please be careful. Now, we will go one by one. What is the first one? You want to say what is the first one? Recursion. So, I am really saying to you, these are the basics which are required for divide and conquer. So, basics of divide and conquer. Without these basics, divide and conquer, you cannot do. Recursion, recurrence relation, solving. Right? Let's start the first one, recursion. Right? First one is recursion. So, if you are comfortable with the basics of the divide and conquer becomes very simple. Let me say one more interesting thing also. If divide and conquer is over, algorithm subject almost completed. Please be careful. Main topic in algorithm subject is divide and conquer only. Most of the things will come in algorithm subject in any competitive exam from divide and conquer only. Everything is important, but divide and conquer is more important because many things are there inside divide and conquer. If you want to get the divide and conquer clearly, basics you have to get clearly. See the first one, basics, recursion. Right? Recursion is the first one. Right? So many people know the definition also. Right? Now I am saying the definition. Right? If anyone don't know, please take care. Many people know, as a computer science person, many times you listen this keyword, recursion, right? Repetitively doing is called as recursion. Repetitively doing is recursion, right? If anyone say, maybe that is right, but if I want to say in the better way, repetitively doing the same thing. Repetitively doing the same thing, that is called as recursion. If you do every time, right? If you do many times, right? Different things, that is not a recursion. Recursion means doing the same thing again and again. Doing same thing again and again is known as recursion. If I want to say programming language terminology, I am saying now, a function calling that itself again and again, right, to solve a given problem is known as recursion. I am writing now. See the first point. See this one. I think everyone know. Only for namesake I am writing. See this one. A function calling that itself is known as recursion. That is the definition. A function calling that itself is known as recursion. Right? If you want, I will give the small example. See this one. One example I am giving. See this one. There is one function named A. Right? See this one. Normally function A, if you go inside, maybe function B called. Normally inside function A if you go, maybe, right, function B called, maybe function C called, function D called. But in the case of the recursion, what happened is, inside A if I go, some work maybe I will do, right? Inside A if I go, some work maybe I will do. At some point I will call A again. This is known as recursion. A function calling that itself is known as recursion. See this one, A internally calling A. Right? Here some work is there. After that work is over, this story. Suppose some students are asking me, right? A is calling A, that's okay. When will you stop? Nothing there. When you are coming, so A is calling A, when you are coming like this, right? Here maybe you can stop. If at all this story is not there, A calling A, it will go to something like infinite loop kind of thing, right? So whenever A is calling A, before some code is there. right? According to that code, I may go further, I may stop, right? If at all, if you stop here, that is called stopping point. If you go further, A will call A. Now again I am asking, what is the meaning of recursion? A function calling that itself, right? Some people are asking, right? That is known as recursion every time. I am repeating the definition. See, a function calling that itself is known as recursion. Some people are asking, sir, why are you calling again and again? To solve a particular problem. In algorithm subject, whatever you do to solve some problem. That is the reason you are calling. So this is the one example. Right? Fine. I am thinking that you are really fine. Let me give one more example. See this one. One more example I am giving. Right? This I will cover a few more points. Definition I written. Right, one example I given. Let me give one more example. Let me explain normal way. See this one, normal way. See this one. Factorial of 6 is equal to, what is the answer? I want to find out factorial of 6 value. What is the answer? If I want to find out a factorial of 6 value, right? If I know answer, what is the factorial of 6 value? I think 720. Factorial of 6 value is 720. If someone asks you what is the factorial of 6 value, if you know answer is 720, you say directly. If someone asks you what is the factorial of 6 value, if someone asks you, if you know answer already, please say directly. Please say directly. If you know answer, say directly. If you don't know. But if you know how to calculate, you can say like this also. Factorial of 6 is 720. If you know, you say. If you don't know, you can say like this also. What is the answer? Factorial of 6 is equal to 6 into factorial of 5. Like this also you can say. This is also correct. If someone asks you what is the factorial of 6, if you know, you say. If you don't know, just go one step back. 6 into factorial of 5 also you can say. What is the factorial of 5? 120. 120 into 6 is 720. That is also okay. Just go one position back. Right? If you know at least factorial of 5, that factorial of 5 into 6 you do, you will get the factorial. Instead of saying I don't know, this may be better idea. Some people are asking me, sir, if I know factorial of 5 value, I will find out, right, into 6, then factorial of 6 will come, that is okay. But suppose that I don't know factorial of 5 also. I don't know factorial of 5 also. What is the answer? Continue same story. What is the meaning? 5 into factorial of 4. Just continue like this. That is the meaning of recursion. Do the same story again and again. First place, I don't know. Right, whatever you done, next also same, until, right, the thing which you know will come. Until the thing which you know will come. If I don't know, continue again. If I don't know, continue. Some people are asking me, factorial of 4 also I don't know, same story. 4 into factorial of 3. What is the factorial of 3? 3 into factorial of 2. Right? So if you know at anywhere, you stop. If you don't know, continue further. Can you say what is the factorial of 2 value? Factorial of 2 value is 2. Right? If you know that, stop. If you don't know, if you want, you can continue further. Until your required thing will come, continue. So what is the answer? This is going to be 2 into factorial of 1. Right? Right, factorial of 1. Everyone know. What is the factorial of 1 value? Factorial of 1 value is 1. Everyone know. Everyone. You should know something. Right? If you want to do anything, little bit you have to know. You may not know big things. At least smaller thing you should know. Right? So 6 calling 5, 5 calling 4, 4 calling 3, 3 calling 2, 2 calling 1. 1 you know, then you can stop. Can you help me now? What is the factorial of 1 value? See this one? Factorial of 1 value. I think you should know something. This is the one which you know. Assume that. Factorial of 1 is 1. What is the 2 into 1? 2. Right? Then you have to return 2. 2 will go now. It is 2k. What is the 3 into 2? 6. 6 will go. It is a 6. Next one. What is the 4 into 6? 24. 24 will go. Next one. What is the 5 into 24? What is the answer? 120. It is the 120. Next one. What is the 6 into 120? What is the answer? 720. So like that. At any point if you know, right? I think using that, right? Just you can continue back. So whatever way you came, right, in the reverse order you will go back. Now can you help me one small line now? Now some students are asking me, sir, where is the recursion here? If you want, you can check where is the recursion, right? Fact calling fact. See this one. Fact calling fact. Fact calling fact. Fact calling fact until the thing which you know will come. Let me do this. See this one. Here fact is calling. See this one. Fact is calling fact. Here fact is calling fact. Here also fact is calling fact, like that. Until the thing which you know will come. I think this is the one which I know. Next one, whatever way, listen, whatever way you came, in the reverse order you will go back. Now one more thing I want to ask you, who called first? Who called first? Factorial of 6 called. Function name is fact only, value 6. Who called first? Factorial of 6. Next, factorial of 5. Next 4. Next 3. Next 2. Next 1. Right, like that. Next one. So can you help me one small now? Who called first? Factorial of 6. Is he completed immediately or he is waiting for someone? He is waiting for factorial of 5. Factorial of 5 completed immediately or he is waiting for someone? He is waiting for factorial of 4. Waiting is going on. Whoever called first, he have to wait long time because he is depending upon so many people. 6 is waiting 5, 5 is waiting 4, 4 is waiting 3, 3 is waiting 2, 2 is waiting 1. 1 is not waiting anyone. I think can anyone help now? How many people are called total? 6, 5, 4, 3, 2, 1. Right? I think 6 people called. 6 people called. Who called first? Factorial of 6 called. Who called last? Factorial of 1 called. The person who called last, he will be complete first. Because he is not depending upon anyone. 6 called first, afterwards 5, after 4 and so on, afterwards 1. But 1 is called last, he will complete first because he is not depending upon anyone. So, because of he is not depending on anyone, right, he will complete first. This value will be sent to the previous one, he will complete and so on. Can you help me now? Right? Who completed first? Fact 1, next fact 2, next fact 3, fact 4, fact 5, lastly fact 6. Whatever order you called, in the reverse order you are executing. In the reverse order they will be done. Who called first? Factorial of 6. Who completed last? Factorial of 6. Whoever called first, he will complete last. I think everyone know. This is called as stack property. What is the meaning of stack property? First in, last out. Who came first? He have to go last. That is called first in, last out. And one more way of saying last in, first out. Who called last? Factorial of 1, but he will complete first. This is the meaning of stack property. See, stack means not diagram. Stack means property. Can you say what property you are following here? Last in, first out, or first in, last out. Means indirectly, directly I am saying to you. Can you say how many functions are called? 6 people. If 6 people called, because of many people you called, they have to wait somewhere. If they don't wait, right, you may lose all of them. Because of you called many people, they have to wait somewhere. Some people are asking, sir, why they are waiting? 6 to complete 5 required. 5 to complete 4 required. So all are waiting. Where they will wait? They will wait in the stack. Because you want that kind of behavior, then why don't you wait in the stack? If you want queue behavior, wait in the queue. If you want stack behavior, wait in the stack. If you want array behavior, right, store in the array. Depending upon what kind of behavior you want, you take that kind of data structure. Many data structures are there. Which data structure you are taking here? Yeah, right, stack. I think it's the correct time to ask you to execute the recursive program. Inside the computer, which data structure you are using? Stack. What is the reason? Stack property I want. So I have to use stack data structure. Some people are asking, sir, can I take queue? Using queue, if you want to implement stack, I think it will time consuming, unnecessary. Right? You want stack property, then take stack. If you want queue property, then take queue. Right? Taking queue and you want the stack behavior, unnecessary, some more extra work you should be done. Everything possible with everyone. Right? Some will take less time, some will take more time. You want stack behavior, then take stack. I hope everyone fine now. Now I think it's the correct time to ask you, who called first? Factorial of 6. Try to remember, function called means push. Function over means pop. When you say stack, push and pop there. When push, when pop. Function call, push. Function over, pop. Can you help me? Who called first? Yeah, factorial of 6 called, push. Factorial of 5 called, push. If you don't push, you may lose them. Right? You bought something, right? Just store in the house. Otherwise, you may lose it. So, 6 called push, 5 called push and so on. What is the last one? Factorial of 1 called push. But one thing, he is not depending upon anyone. He will complete, immediately pop. Right? See this one. This is the way how they came. Right? This is the way they are going. See this one. I think going back means pop. When you say that this is over means pop. When you say this is over, pop. So in the programming language is nothing but return. Return means over. Return means pop. Return means pop. Right? When you say call, push. Right? When you say function over means our return, pop. Right? Like that it will happen. I'm thinking that you are really absolutely you are fine now. Now can you help me now? Where is the recursion here? See, this one, fact calling fact many times. It is the recursion. Now one more thing I want to ask you. By seeing this entire example, can you say what is the meaning of recursion? Recursion means a function calling that itself. That's okay. One more definition, one more nice definition for recursion is going to be, recursion is nothing but solving bigger problem in terms of small problem. What is the meaning? Factorial of 6 I am solving in terms of factorial of 5. Factorial of 5 I am solving in terms of factorial of 4. What is the meaning? Solving bigger one means factorial of 6 in terms of factorial of 5. Solving big problem in terms of small problem is known as recursion. Many definition, but meaningful definition this only. A function calling that itself is known as recursion. That is the one definition. One more definition. Right? So, solving big problem in terms of small problem is known as recursion. Two examples I given. One is the normal example, programming way. One more meaningful example. Both are okay. Here also A calling A. Here also fact calling fact. But I shown you with the help of example what is going on. Let me write the second point. First point is okay. This is the first point. Function calling that itself is known as recursion. See the second point. See the second point now. Solving big problem into small problems. Solving big problem in terms of solving big problem using small problems. Let me remove. Right, solving big problem using small problems is known as recursion. I am repeating second line. Solving big problem using small problem is known as recursion. Right? This is also right. Calling that itself is known as recursion. That is also okay. Solving big problem in terms of small problem is known as recursion. That is also okay. But second point is, it's a meaningful definition. Instead of saying 1, say 2. Definitely some positive things will happen. Right? That is the second point. See the third point. Now. Can you help me now? Whenever recursion is going on, calling, it's okay. But where will you stop? Right? Until termination condition will come. You have to keep on calling like that. Right? So supposing that for the given program, for the factorial, assume that. Right? Termination condition not there. What is the meaning? Stopping point. Calling, wherever calling you stopped, that is called termination condition. Stopping point. Every recursive program should have termination condition. Assume the termination condition not there. What is the answer? You are keep on pushing. Factorial of 6 push, factorial of 5 push and so on. 1 also push. Right? Assume that termination not there. Right? 1 also I don't know. Then what is the answer? 0 call. 0 also I don't know. -1 call. -1 also I don't know. -2 call. Calling is nothing but push operation. You are keep on continuously pushing. But everyone know, inside a computer there is a one stack. That is called system stack. You are keep on pushing, right? So there is no ending for there is no termination condition. You are keep on pushing, system stack is over. Then you will get, right? Then the program what you written one recursive program without termination condition. So when our program is running, right? Inside computer, continuously push operations are going on, stack size over, while running you will get one error message. What is that one? Stack overflow error message. The system stack, whatever is there inside, right? Unfortunately, because of you didn't written the program properly, because of logic is wrong, termination condition not there, you written the recursive program. That is the reason this mistake happened, right? From the computer side, there is no problem. From your side, your logic is wrong. That is the reason total system stack is completed. You will get error message, stack overflow. You don't go to infinite loop, right? In between only. You want to go to infinite loop, but infinite space not there. Every infinite calls you done. Right? You want to do infinite calls, but in between only, right? In between only stack is over. So you got the error message, stack overflow. So try to remember, stack overflow happened, right? Infinite loop not happened. You want to go to infinite loop, but unfortunately stack size over, it is not possible. So I think what is the answer? So program is terminated in between because of stack overflow. Right? So some people may say infinite loop. No, actually it is not infinite loop. They may say, but their intention also same. Infinite loop means what? Space is completed. Their meaning may be like that, but actually it is not infinite loop. Right? Let me write the third point. What is the answer? Every recursive program should have termination condition. Recursive program should have. Recursive program should have termination condition. Should have termination condition. Every recursive program should have termination condition. Otherwise, stack overflow error message will come. Stack overflow error message will come. Otherwise, stack overflow error message will come. Right, fine. Every recursive program should have termination condition. Otherwise, stack overflow error message will come. Right, please be careful. Next one, 4. To execute the recursive program, which data structure you are using? Stack. Right, to execute recursive program. To execute recursive program, we are using stack data structure. To execute recursive program, we are using stack data structure. Some people are asking, sir, why not queue? I don't want queue behavior. I want stack behavior, so I am using stack. First of all, why are you using data structure? Many people are there. If only one, you may not no need to store. You can store in one variable. Because many people are there, you have to use one data structure. Right? Many are there, you cannot keep outside. Only one person, one variable enough. Many people are there. They are also coming in the systematic order. Right? Data structure can hold in the proper order. Right? Please be careful. To execute recursive program, we are using stack data structure. 4, that is okay. 5. Right? 5th point. Now one more thing, see this one. One more interesting answer. See the 5th point. These all points are really important to you. See the 5th point. Whenever recursion is going on, you only say, whenever recursion is going on, a function is calling that itself, it's okay. But one thing, one function call to another function call, what is the change? See this one? This function name also fact, this function name also fact. But what is the difference? Right? Here value is 6, but here value 5. Here value 4, here value 3, here value 2, here value 1. So what I want to say, whenever recursion is going on from one function call to another function call, what will be the difference? Whenever recursion is going on from one function call to another function call, what will be the difference? Name of the function? No change. Next one, name of the parameter? No change. Next one, number of the parameter? No change. The only thing is names of the parameters will not change. Number of parameters also will not change. Function name also will not change. The only thing is parameter value will change. Parameter value will change. Please be careful. One function call to another function call in the recursion, right? Name of the function will not change. Number of parameters will not change, right? Number of parameters will not change. Name of the parameter also will not change. Function name also will not change. But what is the only change? Parameter value will change. Function call to one function call to another function call. Parameter value will change, but not other things. Right? Let me write. 5th point. One function call to another function call. One function call to another function call in recursion. One function call to another function call in recursion. Parameter value will change, but not other things. But not other things. I am repeating the 5th point. In recursion, right? So I written here. See the 5th point. One function call to another function call in recursion. Parameter value will change. Parameter value will change, but not other things. Other things means what? Names will not change. Number of parameter will not change. Function name will not change. Only parameter value will change. Right? So 5 points I said to you. Right? Please be careful. right? So I will cover the remaining point also. Every point is important here, please be careful. See the next one now. Right. So see the next one. To say the next point I am writing something, please listen. Please listen this also. Please listen this. You are using stack data structure. That's okay. Can you help now? What is the first function call? You only say what is the first function call? First function call, if you see factorial of n. First function call is a factorial of n. What is the code? N into fact of n minus 1. This is the code. Factorial of n is equal to n into fact of n minus 1. Some people are asking, sir, what is the n value? N value 6 here. Factorial of n is equal to n into fact of n minus 1, right? So n value 6 here. Now, because of it is the function call, again push. Same. What is the answer? Factorial of n into fact of n minus 1. So, but here n value 5. One function call to another function call. What is the answer? Name will not change. Right? Code will not change. Same code, everything same, but value will change. Because of it, the fact of n minus 1 again, right? Call fact of n. What is the answer? N into fact of n minus 1. So here n value 4. Same. Because the fact of n minus 1 again call fact of n. What is the answer? N into fact of n minus 1. So here n value 3. Because the fact of n minus 1, same story. Fact of n. 2. N into fact of n minus 1. Because the fact of n minus 1, same story. What is the answer? F of n. N into fact of n minus 1. Here n value 1. N value 1, stop. Right? See this one. I think fact of n minus 1. Let's see this one. Let's see one small mistake. So because of n, right? It is a small problem. Right? Termination condition. So what is the answer? 1 will be there. Here 1 there. So fact of n 1, right? 1 is there. You don't call further. They all are calling because we don't know that value, right? But this value you know, then stop it. Now see the reverse. See the reverse now. How they are executing reverse. See the answer. Because of this value you know. What is the answer? 1. This 1 will come back. See this one. That is the meaning of return. Return means over. Because of this one you know, means it is over. Over means return. Returning value will come 1. Can you say what is the n value in this block? N value in this block is 2. It is the 2. 2 into 1 is 2. 2 will return like this. It is the 2. What is the n value in this block? 3. It is the 3. 3 into 2, 6. 6 will come back like this. It is the 6. What is the n value in this block? 4. 4 into 6. What is the answer? 24. Right? 24 will go back like this. 24. Right? What is the n value here? 5. 5 into 24. What is the answer? I think 120. 120 here. What is the n value in this? 6 will be there. 6 into 120, 720. Like that it will come. All white color things coming back. Right? All the red color things, right? Going top. See, this is red color things are, I think, going further. Push operation. All white color things are going to be. What is the answer? They are going down. Means pop operation. So this is the stack data structure you are using. See this one. Same code. Same code. Next one. Same function name. So next one, number of parameters also 1. Parameter name also n. But value is keep on changing. And one more thing. Can you help me now? How many stack units you utilized? How many stack units you utilized? I think 6 stack units. This is called depth of the stack. This is called depth of, whenever recursion is going on, how much stack space you used, that is called depth of the stack. Depth of the stack. Right? Let me write now. 6th point. The number of stack units, not stacks, so one stack only, but that stack contain many units. The number of stack units utilized while recursive program running is known as depth of the stack. It is known as depth of, I am reading now. See this one. I'm again and again I'm saying to you, see, many times I used to repeat, right? Many times I used to repeat. Let me see. See this one. The number of stack units utilized while recursive program is running is known as depth of the stack. How many stack units you utilized? How many stack units you utilized whenever recursive program going on here? 6 stack units. So depth of the stack is going to be 6. The number of stack units you are utilized while recursive program is going on is known as depth of the stack. Right? Fine. So these are the total 6 points. Can you help me now? What is the first point? A function calling that itself is known as recursion. That is the first point. Some example, it's okay. Next one. Right? Another way of saying the recursion, solving big problem. Solving big problem using small problems is known as recursion. That is also okay. Next one. Right? Recursive program should have termination condition, otherwise stack overflow error message will come. Next one. To execute recursive program, we are using stack data structure. Next one. From one function call to another function call, in recursion, parameter value will change but not other things. Next one. The number of stack units you utilized while recursive program is running is known as depth of the stack. Is known as depth of the stack. I am thinking that you are really fine now. And one more. Whatever code you written, right? I will write in the form of your program. See the program. Whatever code you written, right? See this one. Same thing. Whatever you written, right? I will write the program. Very simple. Many people know also. See the program. See the program now. Fact of n. What is the insight? Fact of, someone asking what is the factorial of n? What is the answer? If someone asking you what is the factorial of n, just ask one line. What is the answer? If n is equal to 1, means so it's the termination, then you will call. Fact of n, how much someone asking? Then I am asking first line. Is n is equal to 1? Yes, then return 1. No need to call anyone. Then return 1. Someone asking what is the factorial of n value, I will ask is n is 1 because that is the termination. Termination first check. If you don't check the termination, if you call blindly, there may be chance that, right? I think stack overflow error message will come. What is the best idea? Someone asking factorial of n, immediately ask what is the n value. Is n is 1, termination, then return 1. Suppose isn't that it is the true, then stop. Suppose it is fail, then major line will come. What is the else? Else is going to be this answer, n into fact of n minus 1. This is the major line. N into fact of n minus 1. After getting this one, return. After getting this one, return it. So, if the problem is n is very small, then like this. If it is not small, then call like this. N into fact of n minus 1. Solving bigger one in terms of smaller. Some people are asking, sir, how it will be done? Recursion will take care. Recursion is keep on calling, don't worry. Now, some people are asking, sir, can you give one small example? See the answer, small example. Factorial of 6 I want to find out. What is the answer? 6 is equal to 1, fail. Then, what is the 6 into f of, right? 5. 5 called. Because of the recursion, again it will go. So, n value previously 6, now 5. Again, same story. 5 is equal to 1, no. Then, what is the answer? 5 into f of 4. Again call. Here 4. Next one. 4 is equal to 1. No. Again call. So what is the answer? 4 into f of 3. Right? 3 also called again. 3 is equal to 1. No. Then 3 into f of 2. 2 called. Right? 2 called. Next one. Right? 2 is equal to 1. No. Then what is the answer? Same story. 2 into f of 1. Next one. Is 1 is equal to 1? Is 1 is equal to 1, here 1 there. Here 1 is equal to 1, yes, then return 1, right? I think return value will start now. Return 1, this will goes to now 1. This is 1, right? 2 into 1, all returns are there. This one, same, it is also having return, it is also everyone having return. Return means what? Go back. Return means go back. Return means go back. What is the value? 2 return. It is the 2. 3 into 2, 6 return, right? It is the 6. 4 into 6, 24 return. It is the 24. 5 into 24, 120 return. It is the 120. Right? 6 into 120, what is the 720 return? Right? Like this. 720 return like this. And one more thing I want to ask you. Who is the first person? This one. He is there in the stack. He is the first person. He is there in the stack. Next person in the stack. Next person in the stack. Next person in the stack and so on. He is the last person in the stack. Right? From here termination will start. See, these all are going back. Right? These all are going back. See this. Means pop operation, which is nothing but completed, right? Like this. Same thing. Now let me ask one small line. In recursive program, only 2 steps are there. What is that one? Termination. If not termination, call further. 2 things only. N is equal to 1, then return 1. Otherwise, n into fact of n minus 1. Can anyone help now? Recursive programs will be useful to computer or human being. Recursive programs are beneficial to computer or human being, right? Human being. What is the reason? Recursive programs are very easy to write because only 2 steps are there. Stopping and continue. Stopping is termination, continue means recursion. Last time I want to ask, recursive programs are beneficial to programmer or computer? Programmer. Why? They are very easy to write. They are not useful to computer. Why? Right? Lot of stack space inside it will take. Recursive program is running inside, lot of stack space is there. See, this entire thing is stack. This is the stack. Right? If I want to say diagrammatic way, this is the stack. Same thing. Both are same. Recursive program is not advantage to computer. It is advantage to, right, human being. Because very easy to write. Try to remember always, right? If something is very easy to do, definitely it is harmful. It is harmful to computer here. If something is very easy, right? I think some serious drawback is there. Here, what is the serious drawback? There is a stack inside. Lot of stack space you are using, right? Fine. So, recursive program using stack space. How much amount of stack space you will use whenever this recursive program is running? That is called depth of the stack. Right? That is called depth. And one more. Recursive program beneficial to user but not to computer. If you want, I will write that point also. Write that point also. Roughly I am writing now. Roughly, please you take care. 7th point. Recursive programs are beneficial to user but not to computer. Recursive programs are beneficial to user but not to computer. Right? Please be careful. 8th point. So this is the recursive program, everyone. It is the recursive program. Let me write the same thing, non-recursion. See this one? Fact of n. Non-recursive program. Non-recursion means a function calling that itself is known as recursion. See, fact calling fact, that is called recursion. Right? Here you don't call fact. See how you will do. Fact of n. See this one? For I is equal to 1, I less than or equal to n, I plus plus. Right? See this one. Right? Fact s is equal to, isn't that initially s is 1. Fact s is equal to, what is the answer? S into I. Can you say initially what the s will multiply? S contain already 1. What is initially s multiplied? Right? S contain 1. 1 into 1, 1. Afterwards I value becomes 2. That will be multiplied by 2. That will be multiplied by 3. That will be multiplied by 4 and so on until n value becomes 6. Right? Whenever this loop is over, return s. Right? Then it will give factorial. Just I think first I value 1 multiplied, 2 multiplied, 3 multiplied and so on 6 multiplied. Whenever I value becomes 7 out of the for loop, then return s. Right? This will also find out, right? Remember this one. This is also a program, that is also a program. It is a recursive program. It is a non-recursive program. It is a non-recursive program. In the non-recursive program, loop is there. In the recursive program, same thing can be done using calling himself. In the recursion, call himself if you want again and again. In the non-recursion, just loop. Take one for loop and do that. Right? It is a non-recursive program, that is the recursive program. I think by seeing this one, you can write one line. What is that? Every recursive program, right? Every recursive program contain equivalent non-recursive program. For every recursive program. Equivalent non-recursive program. For every recursive program, equivalent non-recursive program possible. Right? Please be careful. Can you help me now? For every recursive program, equivalent non-recursive program is possible. That is fine. Can you help? Some people are asking, then why 2? Then why 2? Why recursion, non-recursion? Recursive programs are very easy to user. They may be difficult to, right? Non-recursive programs may be difficult to user. That is the reason always user comfortability matters. Forget about the system after, right? Afterwards, we will think about system also. First to concentrate about the user. User happy, then only will buy computer, then only will do programming, right? So please give a lot of flexibility to the user. Recursive program also, user want to write some program, just say to him, write whatever you want. Recursion, write. Non-recursion, write. First to write something. Afterwards, right, in his computer, space is over. Then you want to write the efficient program and all. Then say to him, in the place of recursion, you can write non-recursion also, so that you can save some space. But can you help me one small line? Is it recursion or non-recursion? It is a recursion or non-recursion. So it is a non-recursion. There is no stack, nothing there. Right? I think a stack space, right? Previously huge stack space. Right? Now some people are asking, sir, here stack space it will take or not? Here also stack space, but one function call, one unit. It is also, see, fact of n called, but you don't call anyone further. So here also it is also program, this is also program. It is a recursive program, many function call. It is a non-recursive program, one function call, one unit. Here many function call, many units. Can you help in a space point of view, who is better? Non-recursive program. For user point of view, who is better? Recursive program. Right? Please be careful. Comparing recursive program, non-recursive program, who is better? Right? Recursive programs are better for user, non-recursive programs are better for computer. Why? Comparing recursion, non-recursion will take less stack space. Right? If you want, I will write that line also. See that point also. 9th point. Comparing recursive program, non-recursive program will take less space, less stack space. Comparing recursive program, non-recursive program will take less stack space. Right? These are the 9 points. Please be careful. All points are very, very important. So only for namesake I am reading. Please make the proper notes from your side. Right? Everything I cannot keep on the board. It is very difficult also. That is the reason I written roughly instead of not writing. Roughly I written. See this one. What is the first point about the recursion? A function calling that itself is known as recursion. Next one, solving big problem in terms of smaller problem is known as recursion. 2 definitions. 3, recursive program should have termination condition, otherwise stack overflow will come. Next one, to execute recursive program we are using stack data structure. 5th point, one function call to another function call in the recursion, right? What is the answer? Parameter value will change but not other things. Next one, the number of stack units utilized while recursive program is running is known as depth of the stack. Right? I think you are using 6 units of stack. I think depth of the stack is 6. Next one. 7th point. Recursive programs are beneficial to user but not to computer because it is taking computer some space. Right? But they are useful to user because recursive program contain only 2 steps. Right? How to stop, how to continue. Termination fail, then continue further. Termination pass, then stop. Every recursive program contain only 2 steps. User point of view, it is a great idea. It may take, right, definitely all positive points cannot come. Some negatives, some positives. Right? Fine. Next one. Recursive programs are beneficial to the programmer but not to computer. It's okay. Next one. See the 8th point. For every recursive program, equivalent non-recursive program is possible. For every recursion, non-recursion possible. For every non-recursion, recursion is possible. But some may be difficult, some may be easy. But one thing, for one to each other possible. Please be careful. Google possible, WhatsApp possible. What is there here? For every recursion, you can write the equivalent non-recursive program. The only thing is going to be, you have to spend some time on that. If you spend some time, automatically you will get it. If anyone say, for the recursion, equivalent to non-recursive program not possible, if anyone say like that, like Google possible, WhatsApp possible, Ola possible, Uber, they are very complicated problem. they are able to solve what is there here. The only thing is some are easy, some are difficult. Right? Fine. Next one. See the next one now. 9th point. Comparing recursive program and non-recursive program. Non-recursive program will take less tax space. Is comparing recursive program. Non-recursive program will take less tax space. Right? So non-recursive program means loops only there. Right? More function calls, maybe more space. That is the problem with the recursion. But in the non-recursion, less function call, less tax space. See, I am really saying to you, please try to understand this line. What is that line? Right? If you go to any interview, if they ask you, please explain recursion. You went to one of the computer science technical interview, they asked you, luckily, right? Please explain recursion. If they ask you, please explain the recursion, right? I think inside your brain. What is that one? Today is your day. You enter into the one of the computer science technical interview, they are asking you, right? Please say what is the meaning of recursion, right? Then control yourself. Don't give answer directly. Then control yourself. Think inside, okay, every dog has its own day. Today is your day. Think like this. The wonderful opportunity to complete the interview successfully. Please be careful, right? Then plan. What is the meaning of planning? These all points you have to say. Don't say in the by-hearted manner also. Recursion, explain, right? They are asking, right? It is the wonderful opportunity to explain, right? To say all the things whatever you know about the recursion. So control yourself, take the pen and paper, write properly. First point, recursion definition you say. Second point also you say. Third point, after every point saying, explain properly. While writing, write properly. Don't write whatever way I written. Because of I explained many times, right? Maybe I written roughly, right? I am saying also roughly I written. Because many times I repeated. When I don't repeat, right, I will write clearly. So I am doing both the things, right? That is the reason roughly I written, right? Please be careful. So say all the 9 points you say. Don't say in the by-hearted manner also, meaningfully you say. So if you can present these 9 points properly, right? I am saying to you, at the end of these 9 points, half an hour time is over. You done really nice justification. They will give job to you. If you say one line only, recursion means function calling that itself. If you stop, who will give the job? First of all, are you happy with your explanation? Right? No. Then you are not happy. How others are happy? Right? Please be careful. If anyone asks you, explain recursion from today onwards, I am really saying to you, you should be proud of your explanation. All 9 points say properly, write properly, use different colors if possible. Because when you are explaining, they are checking many things. What about your communication skills? One person is checking in the interview your communication skills only. One person is checking in the interview your writing skills only. One person is checking, right, in your explanation how you are presenting, how you are writing. One person is checking your technical skills only. One person is checking your confidence. Right? These many people are there. Right? So if you are whenever any opportunity will come, technical interview means everywhere, right? Every interview you may not get the technical interview opportunity. Sometimes maybe, right? Starting round itself you may go. If you got luckily some technical interview opportunity, right? So please present all your skills properly. All your skills. You may be good in writing, write it. Otherwise, how the other people knows that your writing skills are good or bad? You may be so good in talking, right? How they know when you don't talk? So, please present all your great skills, right, properly. Right? I am saying to you from today onwards, if anyone asks you, explain recursion, right? It should be the end of the interview. Because you should get the job after this. Please take care, all these points. So, can you help me now? Divide and conquer basics, recursion, recurrence relation solving. I hope you got the recursion, these all points, right? Now, we will go to the recurrence relation. Right? See this one. What is the recurrence relation? Let me explain this. Can you help me now? Is it recursive program or not? See, let me, if you want, I will make little larger. Is it recursive program? Fact of n, if n is equal to 1, return 1, else return n into fact of n minus 1. Is it recursive program or not? Yes. Now see, if it is a recursive program, same thing you write in the form of a mathematical relation that is called as recurrence relation. Let me write now. Recurrence relation. right? Let me write how. See this one, fact of n is equal to recurrence relation. I'm writing same thing right in the form of a mathematical relation, that is called recurrence relation. See, fact of n is equal to, answer is 1, fact of n is 1 if n is equal to 1. Same thing, first point. See, what is the first point? This one, this is came like this, came, right? See the second point, fact of n is equal to 1 if n is equal to 1, it's okay. Otherwise, what is the answer? N into fact of n minus 1 if n greater than 1. If n greater than 1, right? So this is second point, it is the second point, same thing, right? Please be careful. Same recursive program show in the form of a mathematical relation is known as recurrence relation. N is equal to 1, then answer is 1. Otherwise, means if n greater than 1, n into fact of n minus 1. This is called as a recurrence relation. Try to remember, if a recursive program is there, you can write the recurrence relation. Not only for this problem, next problem also you can do that. So until now we discussed about what is the recursion, right? What is the recurrence relation? Every recursive program you can write the recurrence relation like this. Next one, this recurrence relation some people are asking, sir, how to solve, right? That is the next story. Recurrence relation solving, afterwards I will explain. Because there are 3 methods are there, right? Let's comfortable these 2 things. Afterwards, recurrence relation solving, how I will explain to you. Be comfortable until now. If anything is not clear, please go back my explanation because many times I repeated. Right? Fine. Yeah. So this point also please take care. See this one, it is the recursive program, it is the non-recursive program. See everyone, it is the recursive program, it is the non-recursive program. We are already done. Now next one, can you help me one small line now? This recursive program, right? This recursive program, whatever is there on the board, this recursive program, please help me. What is the time for this? What is the space for this? Let's check. See this one. What is the time? What is the time complexity for this recursive program? Time complexity for this recursive program. You only say, whenever time complexity means you know very well how many times you called. Time complexity means loops only. Time complexity means loops only. Can you help me now? Whenever this recursion is going on, how many times he called himself? See this one. 6 call 5, 5 call 4, 4 call 3 and so on. What is the answer? 6 will call 5, 5. I think these many people. 6 is given, I think 6 times. If n is given n time, so time complexity, what is the answer? Big O of n times called. 6 calling 5. So everyone now, time complexity means loops only. Everyone now loop, right? Fact, recursion is nothing but loop only. 6 call 5, 5 call 4, 4 call 3, 3 call 2, 2 call 1, right? 1 is a stopping point, you will come back. N push operations, N pop operations. See this one, N push and N pop. Whenever this recursion is going on, N push you done, N pop you done, which is nothing but 2n. Which is order of n. N push operations, N pop operation. Right? Time complexity is going to be big O of n. Right? Everyone know this one. Time complexity means loops only. Right? I think here loops. What is the answer? Fact is keep on calling. Every call is a push operation. Whenever it is over, return back. I think N push, N pop, totally 2n. I think a push also will take some time, pop also. N push, N pop, totally 2n, which is nothing but big O of n. So time complexity asymptotically big O of n. Right? Can you help me now? What about space? Let me write the space. What about space? Please answer. Space complexity is going to be input plus extra. Space complexity is going to be input plus extra. What is the input here? I think what is the factorial of n? N is a one integer, 2 bytes. What is the extra? Whenever recursion is going on, stack units. I think factorial of 6 means 6 units of stack. Factorial of 10 means 10 units of stack. Right? Factorial of n means n units of stack. Assume that everyone is 1 unit. Right? So what is the answer? Input plus extra. What is the input here? 2 bytes. Integer. Extra. What is the answer? N bytes. Because factorial of n means I think n units of stack required. N bytes totally. What is the answer? Big O of n. 2 bytes and n bytes. Finally. Right? What is the answer? N plus 2 byte. Forget about 2 is a constant. Byte is a unit. Finally big O of n. This is the time and space for the which program? Recursive program. To this recursive program. Time is everyone know. Recursion means keep on calling. What is the meaning? Loop. How many times you call? How many times? N time. But whenever calling is going on, N push operations, N pop operation. So forget about 2 also. Simply N times you call. Order of N time. Next one, what about space? Because of it is a recursive program, so right, because of it is a recursive program, a lot of stack space you are taken. Factorial of 6 means 6 units of stack. Factorial of n means n units of stack. This is the extra. This is input. Input is 2 bytes. 2 bytes plus n byte, finally big O of n. Normally people will ask extra only. People normally will ask extra only. Extra space n bytes. Space then total. Right? Space means total, input plus extra. Input is going to be 2 bytes. Extra is going to be stack n bytes. Totally big O of n. Now come to the non-recursive program. Non-recursive program finding time complexity you know very well. Everyone, time complex means loop only. Can you see this loop is how many time? N time. So let me write now time complexity. What is the answer? Big O of n. N times loop going on. Right? I think some people are asking, sir, why don't you write so many statements, or it is also statement, right? It is also statement, it is also statement, it is also 3n, which is nothing but big O of n. You know very well. Forget about small thing. Loop is how many time? N time. So time complexity n. Next one, can you help me? What about space complexity? Let me check here. Space is equal to input plus extra. Can you say input? What is the answer? Factorial of n, 2 bytes. Can you say what is the extra? If you go extra inside, what is the answer? No recursion, nothing there. Because of this function is called 1 unit of stack, it's okay, right? Only one function call. So internally some local variables and all. See, no recursion is there. One function call, 1 byte. Extra is going to be, right? Something like, right? Very less. You can say constant space. Big O of 1. That may be, I think if you want, you can take S also 2 bytes, I also 2 bytes. Small work. Try to remember whenever one function call. Whenever one function call, if you observe, right, I think 1 or 2 local variables you are taken. So input is going to be 2 bytes, it's okay. But whenever this function is going on inside, right, stack is going to be, I think, inside stack, I think one function call is there, 2 or 3 local variables are there, which may be constant space. No recursion. That is the reason it is taking less extra. Their recursion is there, more function call, more units. Here one function call is there, 1 unit. Right, that 1 unit may be internally 2 local variables, something like that. Can you help me now? To the non-recursive program, input is going to be 2 bytes, extra is going to be, because of one function call, 1 unit. 2 bytes and 1 byte approximately constant. So, space complexity of this non-recursive program is going to be 1. Extra, right, input is going to be 2 bytes, extra one function call, 1 unit of space. I written constant, that may be 1 unit size may be 4 bytes because of 2 local variables. Anyhow, small things don't bother. Can you help me now? Is there any stack? Yes. How many units? 1 unit of stack because one function call. So extra is going to be 1 unit of stack, right? Next one is input is going to be 2 bytes, total 2 constants. If we add, constant will come. Right? Everyone know this one. Recursive program, non-recursive program. Who is beneficial for the space? Non-recursive program. Time point of view, both are same. Now I think it is the correct time to ask you. Recursive program, non-recursive program. Who will take more time? Recursive program, non-recursive program. Who will take more time? What is the answer? Try to remember. Recursion, non-recursion don't decide the time. Time is based on logic. If you write the same logic both the places, same time. Time complexity decided by logic, not the recursion, not the non-recursion, right? But stack space is based on, right, recursion or non-recursion, that matters, right? Please be careful. Can you help me now? For a given, right, see this one, I have one logic. That logic, if I write recursion, that the same logic if I implement using non-recursion, which will take more time? What is the answer? Both will take same time because same logics. Space complexity will differ. Extra space will differ because one is recursion, one is non-recursion. Right? For every recursion, non-recursion is possible. Right? If logic is same, same time. If logic differ, automatically time will differ. Right? Recursion, non-recursion, recursion will take more stack space because of more function calls. Right? I think I took until now one example only, factorial, 9 points I said. Right, time complexity for both of them I find out. I am thinking that some small doubts are there, right? In further examples, right, 1 or 2 doubts are there here. In further examples, you may get more clarity. One example only I done. Some confusion may be there, right? Further example, I think 3 more examples are there. In every example, small doubts you can rectify. From today onwards, if anyone asks you, I have here one logic, to that logic, one logic only there, not multiple logics. I have here one logic to solve a problem. That logic, if I write recursive program, non-recursive program, Same logic only, recursive program, non-recursive program. Which will take more time? What will you say? Logic same, so same time. Because of recursion, more function call, more stack space may be required, but time is same because the logic is same. Logic changes, time will change. Right? Fine. We will talk about normally asymptotically. Asymptotically, both will take same time. Right? So asymptotically, both will take same space or not, we don't know. See this one. If you want, you can check. This recursive program taking order of n space, that is taking big O of 1. Here big O of n, here big O of 1. Right? Stack space we cannot comment. Time we can comment because both are same logics. Right? Fine.